Hello! I'm super excited to start this course with you, but before we do, we need to see where we're starting and where we're ending up so we have a clear path to success. Now, this course has over 200 HD videos and tons of exercises and projects, but they're all broken down into sections to help us learn better. The course is going to start off with Python basics. In here, if this is your first time learning a programming language, it's going to be super helpful. Even for those that know a programming language already, but don't know anything about Python, this section is going to get you caught up to speed with the basics so that you feel comfortable programming. This is a big section, so we actually have two parts. And along the way, you're going to watch me code, but also code yourself and practice coding so that you get comfortable with what Python has to offer. Next, we talk about a professional Python developer environment. We teach you how to use the terminal and the command line, about using code editors like Sublime Text and Visual Studio Code. We talk about using PyCharm, a fully integrated IDE for Python developers, and also how to use Jupyter notebooks, because we're going to use these notebooks later on in the course to do something really exciting. Hint, hint, it's machine learning. And once we have a fully professional developer environment, we then get into some advanced Python topics. Now, this section, we're not going to shy away from any tough topics, but I'm going to help you understand them and make sense of it all. We're going to talk about classes, object-oriented programming, about decorators, generators, error handling, functional programming, as well as best practices when it comes to how to write clean code. And we'll also learn about popular Python packages, how to work with files, how to test our code, how to use regular expressions, and so much more. Your head might hurt by the end of this section, but trust me, it's going to be fun. Now, most courses will be done by then. You've learned Python and you should be all set, right? Well, not really. Because once we've learned this new language, this new syntax, we have our computers set up to work with Python. We need to talk about how we can apply our newfound knowledge. This is the fun part of the course. We start talking about the careers and the career options you have in Python. Then, we get into different fields that we can use Python in. We're going to learn about scripting in Python, where we use Python to send automated emails. We use Python to process images, work with PDF files. We use Python to send ourselves text messages. We build a Twitter bot. And my favorite project in this section is we build a password checker to actually see if the passwords that you use have ever been hacked. It's a really fun one. We also talk about data scraping. A very common use case with Python is to scrape data from online and use it for something productive. In our case, we're going to learn about data scraping and how we can scrape a really popular website for programmers to only select the articles that are important for you to stay up to date with the industry. Again, it's going to be a really fun project. I know I'm saying all projects are fun, but okay, I'm biased. Give me a break here. We're also going to learn about automation, and we're going to use something called Selenium to actually control through our machines a web browser and get the machine to do different tasks as if it's a user. And there's some really fun applications when it comes to automation that we'll talk about. And then, I know, everybody's two favorite topics, web development and data science and machine learning. These two sections are going to be a ton of fun, and I think are going to probably be the most popular sections. In the web development section, we're going to learn how to use HTML, CSS, and JavaScript, as well as Python, to build our own server, build our own portfolio website, put the website online, in production, and have future employers and customers message you through your website. And yes, you're going to get to customize it and do whatever you want to this portfolio website so you have something to show for it at the end of the course. And then the machine learning data science part. We're going to use something called Jupyter Notebooks and Kaggle to access some really interesting data sets. We're going to use libraries like Pandas and scikit-learn to predict which soccer players are going to be the most valuable or are underpaid. We're going to build our own machine learning model using the Iris dataset. And then we're also going to do some image detection where we can feed the machine learning model an image and it's going to predict what the image is of. and you're actually going to see how this magic of machine learning works underneath the hood. As you can see, we have a ton to cover in this course. And by the end of it all, this is all going to fit in together and make sense from the very beginning of Python basics to the very end with machine learning. We're going to take you from zero to mastery. But you know what? The best part of this course is our online community. We have thousands of developers chatting every day, helping each other out, solving problems together, and just talking about the latest and greatest in programming. Now, this is an optional resource for you to use so you can have back and forth conversations with other students and myself, so you feel like you're part of a classroom and you're not doing this all alone. But you know what? Enough talk. I know you're getting excited. I am too. So let's get started. Let's start learning and see why Python has become the most popular language in the world. Hey there, this is Andre. You're about to dive into the course. But here's the truth. Most people won't finish this course. Why? It's because doing a course from the comfort of your home is going to take something away that is one of the most critical parts of doing anything challenging and worthwhile. Accountability. It's a lot harder to stop going to elementary school than to stop watching an online course, right? But here's the thing. There is a way to guarantee right now that you will finish the course and you will get through the ZTM courses no matter how hard they get. And trust me, it's going to get hard because we want to teach you really valuable skills. And they are valuable because they're hard to acquire. And this is why you're here. If you don't finish the course, it's a waste of your money. But if you finish the course, we truly believe it will get you the skills that you want. So this is what you're going to do that might put you outside your comfort zone, but it will be extremely effective in increasing your chances of success. Ready for it? You're going to come join our online classroom. In the next lecture, I'll provide a private link only for ZTM students. In there are 3 things I will ask you to do. 1 is to introduce yourself to the community. You can share as little or as much as you want about yourself. I'm going to finish X course by this date, and put that date in your calendar too. Number 2, go to Accountability Buddy's channel. Oh, that's a mouthful. And find someone who is starting a ZTM course right now at the same time. It doesn't have to be the same course, and you can have multiple partners. You're going to make sure that you each finish the course and the goals you set out to do. Finally, number 3, hang out in the general chat and talk about anything that you want. You will also have course-specific channels that you can chat in. You want to be surrounded by other learners like you to stay motivated and being part of a class. Now in here, we're also going to have virtual hangout sessions with myself, other ZTM instructors, and students. I recommend having the Discord server open as you go through the course and as you are learning. Now, I'm not saying this to sell you something. This is simply a fact of learning. When you learn in a group, when you surround yourself with other learners, when you have accountability, you are more likely to succeed. It's a fact. Finally, throughout the course, as you encounter problems or challenges, don't give up. Come back to our Discord server and ask questions and get help. But most importantly, as you start to learn and grow your skills, come here and help out other students. Teaching and helping others is one of the best ways to retain the information you just learned. If you create this routine around your learning, opening up Discord, start watching the lessons, surround yourself with others that have similar goals to you, you will have the accountability and the support system to finish the course. I promise you. Oh, and another fun bit, when you finish the course, you post your certificate in the alumni channel to become an alumni. And then who knows, the people that really are stars of the community become star mentors. Ooh. Now, this all may sound silly. You may say that you don't need anybody. But trust me, we've been doing this for many years, and there is this consistent trend of those that finish the course, get hired, and find success in their careers. You have to do the things that are uncomfortable sometimes to succeed. So that's it. See you in the next lecture and see you in our community. what is a programming language? If someone asked you this question, can you answer it? Programming is simply a way for us to give instructions to computers. We give it an instruction manual, and the computer follows. Without code, computer programs wouldn't do anything. You wouldn't be able to move the mouse around on your screen. You wouldn't be able to Google things. You wouldn't be able to play Pokemon on your phone, right? I can't just tell my computer what to do. You see, computers don't understand English or any other human language for that matter. So, what language do computers speak? Well, they speak in ones and zeros. All electronics speak that language of on or off, 0 or 1. But writing ones and zeros would be gibberish for us. It's hard for us to communicate like that, right? So humans have developed programming languages that are in between human language and machine language. That is, zeros and 1. Some programming languages are lower level than others. That is, they're closer to machine language. And other programming languages are higher level than others. That is, they're closer to English or a human language. And there are lots of programming languages. You have languages like assembly that is really, really close to machine code. You have languages like Python and JavaScript that are really, really close to English. Okay, that's great. We have these pieces, but what are we missing here? I mean, if I want to find flights to Hawaii, how do we go from here to, well, having, let's say, a website show us a display of all our flights, telling the computer to show those flight information on our screen? What are we missing here? Well, we have these programming languages that we usually write on a file, such as Python, JavaScript, maybe even Java. And then we somehow need to get these files that we write into ones and zero so that our machines can understand. Well, we need a translator, right? We take our code that we write, what we call a source code, written in a programming languages, and we give that to a translator that can understand that language, but also understands machine language. And this translator just translates these files for us. So what is this translator? It's not really a person, right? I'm not giving my code to somebody and somebody's going to just start shouting at the computer. That would be quite silly. What is this translator? Ready to have your mind blown? Well, it's another program written by a human. It can either be an interpreter or a compiler. Now, Python usually uses an interpreter, usually. And an interpreter, just like a translator, goes line by line through our code and executes our code on our machine. Compilers are a little bit different. They take your code all at once, reads the entire file all at once, and then translates that to machine code. So again, interpreter goes line by line, and each line executes an instruction. A compiler takes the entire file and turns it into machine code. Now, the differences between these two are a little complicated and beyond the scope of the course. And don't worry, we're going to come back to this topic. But I want you to just have this general picture that when we write code, whether it's Python, JavaScript, Java, C or C++, what we're doing is we're typing it in a language that is human readable. We're giving it to one of these translators, like an interpreter or a compiler, and these spit out code that are able to run on our machines. So to review, interpreters translate line by line and execute the line before going to the next line. Compilers translate all lines of a program to a file, usually called a binary, and execute the whole file at once. Now, in the next video, we're going to talk about this process a little bit more in detail, especially on how it works with Python. But why did I start with this? I mean, this is a complex topic. Most developers, especially if they're starting out, don't even know of this process. They just know that they write code and then it runs. So why did I teach this here? Because in order for us to be able to write Python code, well, I can't just write it anywhere, right? If you went right now to your computer, and let's say you opened up a text file like this one, and you started typing Python code, but for now we don't know Python. So let's just say I want to go search for Pokemon. Well, this might be code. We don't know if it is, but I can't just use this, right? I mean, this isn't really Python code, but how would my computer know what I'm talking about? In order for us to start writing Python, we need to download this translation service. And in the next video, I'm going to show you how to do that. I'll see you in that one. Bye-bye. Welcome back. We just learned what a programming language is. It's just a set of instructions that we give to a translator. And this translator can be an interpreter or a compiler. And we give these files that we create, our own code, our source code, to these translators. And they allow us to give instructions to machines, to computers, to phones. So we learned that we need these machines in order for us to write Python, right? How can we get these? Well, we download them. And here we download Python from the Python Software Foundation, from python.org. Now, before we download Python, we're going to wait a little bit. Because in this course, I want you to understand why we're doing things. Not just follow my tutorials, follow my videos, and, well, not understand the meaning and the fundamentals behind why we're doing things. You should be able to teach what you're going to learn. So let's take a pause here for a second. If this is the first time that you're learning a programming language, I have some good news for you. At the end of the day, all programming languages do the same thing. They tell the machine what to do. However, different languages have different ways of doing it. The beauty is that most languages have very similar principles. If this is your first programming language, well, this is going to be the hardest part, learning the first one. Afterwards, every new language you learn becomes easier and easier, in the sense that it's not the same as, let's say, learning English and Japanese, two very distinct languages. In programming, things become a lot easier as you learn that first foundational language. Now, if this is not your first language, and let's say you've written code in C, C++, or JavaScript, and you just want to learn Python, well, you're going to find these first couple of videos quite easy. But bear with me. Trust me. We're going to get into some advanced topics here. And we're going to make you a full-fledged developer by the end of this. But let's go back to this topic at hand, this idea of downloading this translator. The thing is, when people refer to Python, the language, they're most likely talking about the implementation. That is, they're talking not about the language itself, because Python, the language, is just a specification. You can think of it as a document that somebody wrote that says, hey, when I write the words DEF, that means something in Python. And when I write something like print, that means something in Python. But the translation machines, well, we can have tons of them. Different interpreters, different compilers. For example, python.org, when you click download here, you're actually downloading this, the C Python, because it's written in the C programming language. This is what you're downloading. It's a program written in C to read your Python file and, well, run it on a machine. but there's other implementations. For example, there's the Jython project. And this is a translator that is written in the Java language. There's PyPy, which is actually written in Python. So it's a interpreter, it's a translation machine written in Python. And then there's also things like Iron Python, which is written for the .NET framework. So here's a little trick question. When you download from Python, the official language is actually CPython. You're downloading this interpreter that follows the Python specification. But at the end of the day, it's a machine built by somebody. But these machines can, well, come in many forms. So when most people talk about Python, they're talking about this one, CPython, that, well, does our translation for us. It interprets our Python code and runs it on a machine. So we're downloading this. And if you want to really get into details as to what we're downloading, well, we're downloading a machine that takes our Python code, which, don't worry, we're going to write, and it goes through the interpreter, which we download using CPython. And this CPython is going to create something called a bytecode. For example, this bytecode prints hello world on our screen. Now, this might look like gibberish to you. And even for me, I don't know bytecode. This looks pretty, well, confusing, just for printing hello world to the screen. Well, the interpreter does that automatically for us. We don't see it. It's behind the scene. Now, once it creates a bytecode that is closer to machine code, it then uses the CPython virtual machine. Again, just something that runs this code, and then this code gets run on our machine. Now, you're never ever going to be asked this question in an interview. I mean, maybe. And most developers don't know this. But I want you to use this as a reference. That when we write Python code throughout the rest of this course, this is what's happening. We're writing Python. It gets interpreted line by line and formed into what we call bytecode. And this bytecode gets run on the CPython virtual machine, which runs on our computers, our phones, our laptops. And when we're downloading from python.org, we're downloading these two pieces so that once we have them downloaded, we can run Python. All right, that was a tough one. And I mean, we just got started. I hope your brain isn't exploding. Again, this is something for you to use as a reference. But you know what? I think it's time for us to learn how to actually run Python code. And don't worry, we are getting there. We are going to write our first Python program very soon. I'll see you in the next one. Bye-bye. All right. Oh, man, we've been talking for a long time. How can we finally run Python code? I want to start coding, right? Let's download this translation service, right? Well, I'm sorry. Actually, this is something we're going to do later on in the course. And I know what you're thinking. WTF, Andre? But what is this? Kindergarten? I mean, come on. I came here to learn Python. Start teaching me Python. And I know. And don't worry. In this course, we're going to get you to have a professional setup with Python so that when you go into the workforce, you are doing what you're supposed to be doing. We're going to learn how to have all of these set up. First, we're going to have our terminal or command line where we can run Python from right in what we call a REPL. And then we're also going to use code editors like Sublime Text and Visual Studio Code. We're also going to use IDEs or integrated developer environments like PyCharm and Spider. And we're also going to use Jupyter notebooks. And I'm going to show you how to set up all of these on your computer, what the pros and cons of using each are, and how some of them might be used for machine learning while others might be used for writing quick scripts. And I know this is a lot, but it's good to have these skills depending on what type of job you want. And if you're a professional Python developer, well, you should be using most of these. But there's a problem if I start introducing this in the course right away. You see, these tools, you have to install differently based on what computer you have. So if you're using a Mac, a Windows, a Linux, maybe you're using a mobile phone. Because we want to get started right away and write some code instead of worrying about installations and making sure that your computer is all set up, I want to make sure that all of us can get started right away, no matter what device you're on. Now, if you're really keen, head on over to the section where I show you how to install all these on all of your devices so that you have it set up, and you can come back to this section. But I warn you, it's easy to run into problems and get confused when installing these tools. So I recommend sticking with what I'm about to show you, and I promise we will get you this professional setup. No other course is going to teach you all these things. But before I dive into these, we need to learn, well, we need to be able to just have fun and write some code. So what is this trick that I keep mentioning where we don't have to install any of these and still run Python? It's called REPL. You see, instead of us having to download this, we can go to repl.it. And when you go here, you'll get a login screen. Now, I recommend creating an account on here because, trust me, it's going to be very useful. It's one of my favorite tools. And it allows you to save Python files just online. For example, once you log in and create an account, you can just create a new REPL, choose the language that you want to use. In our case, we want to choose Python. We can name our REPL. So we can just call it hey, and we can just create our REPL and check it out. Right away, we have, without ever downloading this Python translation service, we can actually start writing Python right here in our browsers. And this is going to work for anybody that has an internet connection and a browser because this interpreter just runs automatically here. And the beauty with REPL is that, well, you can save these files, you can have different folders. So as we work through the course, you can actually have a folder for all your Python work and just have a really nice organized file structure that you can access anywhere you have internet connection. Now, if you don't want to sign up for repl.it, it's completely free. You can also use this open source glot.io, which again, you go to Python and you're able to run Python online. So take your time, sign up for repl.it, and let's get started with our first Python program. I'm finally getting there. In the next video, we're going to write our first piece of code. No more waiting. It's coding time. So I'll see you in the next video. Bye-bye. Hey, you're still sticking around. That's good. I didn't bore you with all my talking, but yes, in this video, finally, we're going to write some Python code. Holy moly, thank God, I thought that was going to last forever. All right, so what is our first program going to do? Well, let's create a very simple function. And probably the first thing any programmer learns to do, to print our own name. So in here, once you have your repl.it set up, or remember, you can also use glot.io, we're simply going to write print. And then you see over here that it gives us some information, but all we want to do is write brackets, a quote. So you can do double quotes here or a single quote, and just type your name. And if we click run, on the right side, we've just written our very first Python program. Very exciting. But what's happening here? Well, let's look at everything. First of all, if you're confused why my thing is dark and yours might be light, it's because if I go to settings, I've set my theme to light or to dark. I prefer the dark version. But you can change some of your settings. You can change the font size if you want. Based on when you watch the video, this website, the look might be different, but most of the settings should be the same. We see that we have a main.py, which is the Python extension. Any file that has a .py or py is a Python file. So what we've just written here on line 1 is a program that prints, in this case, Andre Nagoye, or in your case, your own name, and we've written it to this file. Now, REPL.it takes this file, already has this interpreter for us. It runs this piece of code, gives this source code of main.py to the interpreter, and runs it right here on our right side. If you look over here, we're using Python version 3.6.1. And down below, we see that, we have Andre Nagoye printed. That's awesome. So this is our code running. Remember this diagram. All we've done is we have our main.py, where we wrote print Andre Nagoye. We gave it to the interpreter that the REPL already provides for us. That interpreter takes our code, converts it into bytecode, and here it'll say Andre Nagoye, and then it runs it in the CPython VM, which was on the right side that we saw. And it finally prints our name because it tells the machine, hey, we want that text printed. So that's what we're seeing here. This is the CPython virtual machine essentially running this code and telling this machine, hey, I want you to print this. All right, but this isn't very exciting. I mean, let's make this program a little bit more dynamic. For our first program, we want to do something more impressive than just print name. So I'm going to teach you another thing we can do in Python, and it's called input. Now in here, I can say input, and you see that REPL, it actually gives me some information saying that, oh, I have this. You can just click here. And this input over here, well, what can we do? This input is going to prompt a user, and if I hover over it, you can see how it's giving me some information. But input simply gives us a way to capture information. So let's say, what is your name? And if I run this code, we see that we have our Python code running, and it's asking me, what is my name with this cursor here? So I can actually type something here. I can say Andre. And if I hit enter, well, there you go. I've just typed in my own name. Nothing that exciting, right? But this is where code becomes interesting because we can store this information on our computer. So again, these are things that we're going to go over in detail in our basics Python section. But just to write our first code, let's assign this to memory. That is, let's say that name equals whatever is the input of what is your name. And then finally, we can just print the name. So remember, the interpreter is going to take this first line. It's going to ask, what is your name? I'm going to type something. That typed information is going to get assigned to name. And then finally, we print name. Remember, an interpreter takes line by line, converts code to bytecode, and then finally runs it. So let's give this a try. I'm going to click run. All right, what's your name? My name is Andre. Did you see that? I typed in my name, hit enter, and then it printed out Andre. So for the final feat, let's greet. So we're going to say print hello, and then plus name. Now, don't worry about the syntax. We're going to go over it. But all we're doing is saying hello and then adding our name to the end of this. So let's see what happens. If I run this and say, what is your name? My name is Andre. And I hit enter. I get hello, Andre, but no spaces. So let's add a little space, hit run again. For the fourth time, my name's Andre, and it says, hello, Andre. There it is, our first Python program. Now, it's not very exciting because it is our first program. We're just learning the steps here. But I hope, because we've covered some of these topics ahead of time, that this isn't just pure magic, right? You understand that this is source code. This is main.py that we give to an interpreter that runs our code line by line and then executes our program. In this case, our what is your name program. How cool is that? This is just the beginning. We're going to get more and more advanced here. See if you can play around with this. We don't know that much about Python yet, but I hope this gets you excited because, well, there's a lot more coding coming along. I'll see you in the next one. Bye-bye. Hey there, this is Andre from the future. Exactly right after I recorded the videos in the REPL, well, REPL.it decided to upgrade their Python interpreter to the version right here. Now, you might be asking yourself, hold on, if I go to python.org, the version of Python is higher than this. As you can see, the latest version of Python is right here. But again, REPL just takes a bit of time, so we are fine as long as the version is 3 or higher. Now, I want you to keep in mind that REPL usually implements the Python interpreter a little bit later because they have to work out some kinks, make sure that it's integrated properly onto their website. So this number might be a little bit lower than what you see on python.org, but don't worry, everything that we do in this course, you're going to be able to follow. As long as we're using Python version 3, we're all set. Now, depending on when you watch this video, this number might be even higher, but again, everything we're going to learn, you're going to be able to follow. Just keep in mind what I said before. That is that these versions are constantly going to upgrade and constantly going to evolve. In this course, we're using the latest version of Python, but because REPL now has a higher version, it allows us to do some neat things that perhaps we weren't able to do in older versions of Python. For example, later on in the course, we're going to talk about something called the walrus operator. And this is a new feature that is new to Python 3.8. And because of that, we're going to be able to use it inside of this REPL. But we're getting ahead of ourselves. You'll see that when we talk about the walrus operator. Anyway, just a quick note. Let's get back into it. Welcome back. Whenever you start to learn Python, it's unavoidable that you'll encounter this topic of Python 2 versus Python 3. So what is this all about? And it's a very important topic. Now, first of all, Python is created by a human, right? As a matter of fact, it was created by this person right here. His name is Guido. Now, a programming language is always evolving. It's not like somebody creates a programming language, it's perfect, and that's it. No, all programming languages are constantly being updated. Just like on your phone, you constantly get software updates. Well, a programming language is constantly evolving to make it better and better because nobody gets it right the first time. And by the way, this is a great video that I'm going to link to. You can check it out in the resources. Now, Python was created in 1991 by this gentleman, and it was actually created with the name from Monty Python, which was a British comedy group. But like I said before, the language is always evolving. And in 2008, Guido decided that, well, Python version 2, which has been used for a very long time, had some things that he and the community wanted to change. So in 2008, they decided to create Python 3, a new version of the language. Here was the tricky part. You see, when you update software, let's say on your phone or even on your laptop, you expect things to keep working, right? Updates are usually good, they're improvements. But some of the features that Python 2 had, they didn't like, or they wanted to change completely. So Python 3 introduced what we call breaking changes. That is, if you updated to Python 3, remember the Python interpreter, the C Python translator that we've been talking about? Well, as soon as you updated that, your Python 2 code wasn't really going to work. It's like updating your phone and then all of a sudden all your apps stop working. That doesn't sound very good, does it? That's pretty much what happened in 2008. Most companies that wrote their code in Python version 2 just kept Python version 2 because, well, for them to upgrade meant that they had to go through their code line by line and make some changes. Now, these changes weren't that significant. For example, I'll link to some resources, but don't worry, these are topics that we're going to cover throughout the course. But different things wouldn't work. For example, the print function, which we've learned about, in Python 2, it didn't have the brackets. It looked like this. And Python 3 used the brackets. So all the code that had print like this would break. Now, the differences themselves aren't that big. I mean, you can read through them and we'll talk about this in the course, but overall, you can learn them in a day. That's why when we learn Python, most of the time we're learning Python 3, but you can use the same knowledge with the older version of Python. Now, you may see some Python version 2 code out there for companies that haven't upgraded, but it's now what we call legacy. That is, come 2020, it's going to stop receiving security updates. So the community, Python community as a whole, is saying, hey, everybody start using Python 3 because we're going to stop maintaining Python 2. So we're going to learn the most up-to-date version 3 in this course, but we're also going to touch on some older topics that Python 2 covers, just in case you encounter them when you work for a company that perhaps still supports legacy code. But as I mentioned, the whole community as a whole is moving towards Python 3. This website, for example, shows you how many big packages, popular Python packages, which we'll talk about, support Python 3. In our case, there's only 4 popular packages that don't support Python 3. So what I'm saying is Python 3 is the way to go. It's the way of the future. That's what we're going to learn in the course, but I want you to be aware of the historical context. And one thing to be careful of when in this course you're searching for answers, or maybe I have some exercises that require you to Google things. For example, if we go to the Python documentation, which is the reference of how, well, what the programming language does, you'll see that you can choose the versions here. And you always want to go with the latest, but you might find some answers online that still use Python version 2. So you want to make sure that when you're searching for answers, that you don't encounter any legacy code. Like I said, 95% of the time, it's mostly the same, but you usually want to keep current with the language. It has the most community support, most up-to-date, most secure language. So, just a quick note about Python 3 versus Python 2. When you hear the word Python, people are generally just talking about both Python 3 and Python 2. And if you remember, in our REPL, when we created our first program, you see that you're using Python version 3.6. This is the default standard version that REPL comes with. So right away, we know that we're using Python 3. Awesome. It's up to date. It's new. The whole community is behind it. Well, most of the community is behind it. So we're all good to go. I'll see you in the next video. Bye-bye. Welcome back. I wanted to answer this question that I get a lot of, even from professional developers that have been in the field for years. So I want to tackle this question really quickly right now. Why are there so many programming languages? Why can't we just have one language that does everything and everybody's happy and we don't have to worry about learning so many programming languages? And here's the thing. In your career, you don't need to know 5, 10, 8 languages. No, you can be a really successful developer, programmer, with just one language, just finding that speciality of yours. And programming languages like Python, Java, and JavaScript offer a lot of opportunities where you don't need to learn another language. But why are there so many languages? If we go to Wikipedia, these are the list of programming languages. And if you're looking through here, you should be intimidated because there's no way in your lifetime you're going to learn all of these. And, well, you won't. Most likely, you're going to learn 1, 2, maybe 3 languages in your entire lifespan or career as a programmer. And different programming languages are good for different things. Just like we have different tools to, let's say, build a house. You can't just build a house with a hammer. You need different tools that are good at different things to assemble what you want. So it's impossible to build one ultimate language when we have so many applications, so many mobile phones, so many computers, so many devices like cameras. So you have low-level languages that we've talked about, like assembly code or C. And then we have higher-level languages like Python and JavaScript. Now, here's the thing. Python is usually slower than languages like C++ or C# or even Java. And we don't need to get into technical details here, but I do want to tell you about a trade-off. You see, you don't really want to write Python code for low-level systems and hardware interactions. If you're taking this course, well, you're probably not even interested in that field. You see, Python, although slower than some languages, is good at one thing and does this really, really well. That is developer productivity. Because Python is so easy to learn, or at least is very similar to the English language, it's become really, really popular for developers to be productive and write code really, really fast and less lines than something like C. So a print hello world, for example, in Python would take, well, just one line. But all languages have their different strength. For example, if you want to build an app on Android or an iOS device, well, you're not really going to use Python. But if you want to do machine learning, maybe you want to build a web server, maybe you want to do data visualizations, build scripts that process thousands of Excel files. Well, in that case, you're going to use Python. And we're going to cover what different things you can do with Python and what Python is really, really good at in this course as we explore different projects later on. But keep that in mind. The reason there's so many programming languages is that every programming language excels at some things and, well, doesn't do so well at others. It's all about trade-off. There is no ultimate language. And if a programmer tells you, hey, my language is the best language, they're probably junior developers that don't know what they're talking about. Everything is a pro and con. Everything has a trade-off. And as programmers, what really good senior programmers do is being able to detect what these pros and cons are and what tool to use for a specific problem. Something that throughout this course, I'm going to try and teach. I'll see you in the next one. Bye-bye. Welcome back. Let's do our first exercise. And this exercise is going to be really easy for you to skip, but I do recommend that you actually do it. I know it's not coding, but it's important because you'll learn that teaching somebody a topic actually helps you learn. So this is the exercise. Based on the videos that you've watched, how does Python work? But don't think about it in your head. I want you to talk to somebody. I want you to teach somebody how Python works. So the first thing you're going to do is go to our community, our Discord community. We have lots of people here. We have about 1,500 people online right now, plus some alumni, plus some star mentors. Well, there's a lot of people. What I want you to do is go to the Programming Buddies channel, if you haven't already, and find a buddy. And with that buddy, whether that person is taking a Python course or taking a JavaScript course, it doesn't matter. Just say, hey, can I spend maybe 5 minutes teaching you how Python works, and see if you can explain it to them, how it works just like you've learned. And then after you've done that, I want you to go find a friend or a family member that has never done programming before and see if you can explain in simple terms how Python works. That is, how Python gets written as source code. We use this translation service called an interpreter to run this code and then, spit out some instruction for our machines. I kind of gave away the answer, but you know what I mean. I want you to practice teaching somebody this, because by understanding these fundamentals, it's going to help you learn more and more and understand how things work underneath the hood as we get more and more advanced. All right. First little exercise. It shouldn't be too hard. I'll see you in the next video. Bye-bye. Now let's get started, shall we? In order for any programmer to learn a language, there are 4 key things that you need to really master for any sort of language, including Python. First are the terms of that language. Sometimes a programming language has different words and different definitions for these words that you're going to have to memorize. Things like statements, variables, instantiation. Really complicated sounding words, but you need to understand what they mean so that you can talk to other programmers. You also need to learn about a language's data type. That is, what sort of data can a program hold? You can think of it as values. Just like in real life, we have different ways to represent values, like numbers, letters, and symbols. In programming, we have these data types to store information. And each programming language has different sort of data types. Next, we need to learn about actions. At the end of the day, all programming is a way for us to tell our machines, hey, store this data and then retrieve this data and perform some action on it. That's all it is, just using memory and performing some actions. So we're going to learn how to perform those actions. And then finally, we have to learn the best practices of each language. There's good ways of writing Python code, and then there's bad ways. So that when we build our applications, our programs, we don't have a leaning tower like this, but we have a solid structure and a solid program. So throughout the course, we're going to learn about these things. But keep this in mind. These 4 things are what you need to become a good programmer. And I want to start the basic Python section with the data types. So let's get started. Let's learn about the Python data types, all the options we have in Python. Now we're back to our REPL.it so we can write some Python code. We see over here that we're using Python version 3.6. That's great. Let's minimize this and start writing our first Python code. Now, we're going to talk about data types. And Python has several available to us. Now, I'm going to list them out for you, and then we're going to talk about each one individually. First, we have something called int. And you see right away when I type, I have the REPL already give me hint, and it's highlighting it. If I hover over it, it shows me that int stands for integer. We also have something called float. We have bool, which stands for boolean. We have str, which stands for string. List, tuple, set, and dict. Now, what are these? These are data types, right? A data type is a value in Python. So you can think of it as exactly that, values. So int would represent all numbers, for example. String will represent all letters, for example. And a program is simply instructions that tell a computer what to do. And what does that mean? It's all about storing information, or a data type, and modifying that information. We're taking actions on these data types. So the two crucial steps when learning a programming language is that, well, we have these data types that we need to understand that exist in a language, and then we need to learn how we can manipulate the data, create, store, read, change, remove this data from the machine. Now, these data types are called the fundamental data types in Python. They are the core to the language. Now, after the fundamental data types, we also have something called classes. So beyond these data types, we can actually create our own using something called classes. So these will be custom types. Again, something that we'll learn about. So I can create a class that I can name whatever I want. For example, supercar. Now that doesn't exist, but I can create it, and we'll explore how to do that in the course. Now, besides the fundamental data types, the classes, which will be our own custom types, we also have something called specialized data types. And these specialized data types, they're not built into Python, but they're special packages and modules that we can use from libraries. Now, again, this is a topic that we'll cover later, but these are, you can think of it as extra boosts. Whenever we don't have a data type that we want in the standard Python package, and maybe we don't want to create our own custom types, there are specialized data types that we can use from what we call modules. So you can think of it as extensions that we can add to the language. Again, something that we'll talk about later on in the course. And then finally, there's another type that is a little special called none. And none, as you can see, it's being highlighted, which means it means something in the language. None, as the name suggests, means nothing. It's kind of like the idea of zero in math. It's the absence of value. It's simply nothing. And you'll see why this is important in programming later on. So these are our data types that we're going to talk and we're going to use in our language. Now we're going to start with the fundamental data types, which are nice and simple for us to get through. So let's start one by one. And you know what? Let's start with these two for now. I'll see you in the next one. Bye-bye. Welcome back. Let's talk about our first data type. And you know what? Let's do two at the same time. We have int and floats. Int stands for integer, as you can see here, and float stands for a floating point number. Let's explore that. First, let's start off with integer. An integer is, well, a number. 3 or 4 or 5, these are all integers. In a programming language, you can use integers to do mathematical operations. For example, 2 plus 4. If I run this, well, nothing gets printed because, again, we have to perform some action on these data types. And one action that we've learned so far is this idea of printing. And we print something by calling the print keyword with the brackets. So the brackets is almost like saying, hey, perform this action on these data types. And if we run this, we get 6 right here. Awesome. So not only are we using print, but we're also using the plus sign to perform an action to add the two data types together. And as you can imagine, we can do most mathematical operations, the basic ones. We can do negative. We can do, let's say, 2 times 4. And then we can also do 2 divided by 4. And if I click run here, all right, it looks like everything is working. We've added, we've subtracted, we've multiplied, and then we've also divided. Now here's the interesting part. Up until now, we've used what we call integers. That is, these are whole numbers. There's no decimal places. They're just, well, integers. And a neat trick that I can do here is I can actually say, hey, what's the type of 2 plus 4? If I click run here, all right, let's decipher what just happened. I've taught you another action that we can perform, which is something called type, which tells us, hey, what data type is this? And just like in math, we go bracket by bracket. So the first part, Python says, hey, what's 2 plus 4? Well, that's going to be 6. And it's going to say, hey, what's the type of 6? Well, the type of 6, that's an integer. So it's going to say class int. We don't have to worry about the class keyword for now. That's something that we'll talk about later. But we see here that we're using int for integer. And then finally, after this gets evaluated by Python, we print out whatever this does, which is class int. Now, check this out. Let's do the same for all these ones as well. So we're going to say type here, and then type here. And if this syntax is intimidating, don't worry. This is something that you get used to. If this is your first programming language, it is not going to be easy because, well, if it was easy, then everybody would be doing it. So hang in there. Trust me, as you practice more, this is going to start making more and more sense. Now, before I click run, what do you think the output of each one of these lines are? Ready? Give it a guess, and let's click run. All right, we got int for 6. We have -2 here, which is also an integer. We have 8 here, which again is also an integer. But then we have float, because 2 divided by 4 is 0.5. What is that? Well, remember, we are talking about 2 data types here. We're talking about int and float. And float is what we call a floating point number. A floating point number is simply a number with a decimal point. In our case, this is 0.5. So it's a floating point number. So if we write a number, let's say we'll do print type, and then I'll say 0.00001. What do you think we'll get? Well, we would get a float. If I do 5.0001, again, we'll get a float. What about the number 0? If I click run, I get an int because, well, there's no decimal points. Why do we need to make this distinction in programming, and specifically in Python? Well, it's because a float takes up actually a lot more space in memory than an integer, right? Because remember, this number, the number 6, this needs to get stored in memory on our machine. And remember that machines don't really understand this. They understand zeros and 1. And they store this number in something called a binary, or binary numbers, which is zeros and 1s. Now, the problem is when you have decimal places like 0. Or let's do 10.56, it's hard to represent that in a binary number, zeros and 1s, because of this point. So a floating point number essentially stores these numbers in two different locations, one for the 10 and one for 56. Now, we don't need to get technical here, but that's the idea. The idea is that we need more memory to store a number like this than a number like this. Now, the topic of floating point numbers is really, really interesting, and I'll link to a resource. But the best way to learn more about floating points, again, it's not super important that you know the technical details. But if you go to floating point number Python, again, you want to make sure that you go to the documentation for version 3. And you can actually learn about floating point arithmetic. And these official documentation by Python are always a good tool for you to use whenever you get confused about something or you want to get a little bit more extra detail. But let's get back to the topic at hand. Both int and float are used for, well, numbers, right? And Python is going to automatically format the type to whatever, well, makes sense. For example, if in here I do 20 plus 1.1, one is a integer, the other one is a floating point number. But when I click run here, automatically Python is going to convert it to float. Let's remove these here so that we don't get confused by them. So if I run this, we see that this whole expression is converted into, well, a float. Now, if I do, let's say, 9.9 here, which will equal to 11, and I click run, these two floats add up to, well, still a floating point number. Because if I remove the type from here, and I click run, it gives me the result 11.0. It keeps the floating point numbers. All right, but at the end of the day, what we care about is that Python works the way we expect it to. That is, we can do mathematical operations. As a matter of fact, we can do a few other things as well. There's also this idea of the double multiply. So this means to the power of. So 2 to the power of 2, well, that's going to equal 4. 2 to the power of 3 is going to equal 8. We also have the double divide. That is, we can do 2 divided by 4. But then we use 2 slashes here. If I click run here, I get 0. This actually returns an integer, rounded down. If I do 3 divided by 4, I get 0. But if I do 5 divided by 4, I get 1. This gets rounded down to an integer. Finally, the last operator that we're going to learn about is called modulo. And it looks something like this. If I do 5 modulo, which is the percent sign, divided by 4, or modulo 4, if I run this, I get 1. Modulo is used to represent what's the remainder of this division. So if I divide 5 by 4, the remainder of this division will be 1. If I do 6 divided by 4 with modulo, and I run, I get 2. 2 is the remainder of 4. All right, let's take a break and learn a little bit more about these numbers in the next video. Bye-bye. Welcome back. Let's continue our understanding of int and float. We talked about the idea of these two data types and how we can use operations on them that we're familiar with from math class, plus a few ones that maybe we haven't seen before, such as modulo or the double slash, or the double multiply for the power of. Now, this is really cool because we can get our computers to do, well, math for us, like a calculator, right? But a programming language also provides for us different actions that we can perform. Now, besides these ones, we also learned that there's a type action that we can take, there's a print action that we can take, but there's also specific math type functions that int and float are able to use that are built into Python. Now, these are called, well, math functions. And functions, something we'll talk about later on, are these actions that we've been talking about. Remember our diagram here? We're starting to learn about the data types and the actions that we can perform on them. Now, in most programming languages, these actions are called functions. And we have a whole section on them. But for now, there's some functions that we can use. So this is a print function, this is a type function. But there's specific math functions, such as round. And you see right away, when I type, REPL is a tool like an IDE that hints and tells us what we can add. So it says round and give me a number and maybe an digit. But let's just worry about the first one for now. So round, if I do 3.1 and I round here, I get 2. Well, that's not right? That's actually the result from up here because we need to also tell it to perform with a function of print. Hey, print to the screen whatever the result of this is. And just to make things easier to see, I'm going to comment this out. So I'm just selecting everything and then pressing Command/, or if you're on Windows, Control/. If I click Run, I get 3 because I'm rounding down the number. So let's say if it was 3.9, I click and I get 4. Again, I'm rounding the number. Another math function that's built into Python is something called ABS. And you see right away that I get ABS here. And ABS returns the absolute value of the argument. And again, for those that aren't too familiar with math, an absolute value simply means, well, no negative numbers. So an absolute value of negative 20 is 20. And now, because we know about math functions, I can start Googling, right? I can say, hey, I'm a Python programmer and I want to learn about math functions. Well, I can go Python 3 math functions. And look at that. Right away, Google tells me that there's a ton that we can use. You don't have to memorize all of these. As a matter of fact, some of these I've never ever used in my programming career. But it's good to know that they have these tools available to you. And as a programmer, this is something that you'll have to get used to. The idea that you won't actually memorize every single action that we can take for each data type. Because some of these are very rarely used. Some of them you'll never use in your career. The key is to understand how to Google them and how to find them. And throughout this course, I will show you the important ones that you're going to see over and over and over. But as a way for you to develop as a programmer, at least you know that this is how you look for answers and find out that, hey, there's different math functions that we can use with numbers. All right, let's take a break and continue in the next video. Bye-bye. All right, this is a big video. Now, these videos are going to be sprinkled throughout the course. They're developer fundamentals video. These are the topics that are going to be super short, but important because as a beginner, it's hard to learn these things because you don't know what you don't know. So what I'm going to try and do in these developer fundamentals is tell you, well, how to avoid the mistakes that I made when I got started. And what a lot of people do when they get started. That is, they don't have a clear path and don't understand what the most efficient way to do things is. So with developer fundamentals, we're going to talk about key things to make you, first of all, efficient in learning Python, but also make you a programmer that is really, really good and that companies want. So what is this first developer fundamental? It's don't read the dictionary. What does that mean? Well, when you're learning a language, such as Python, you're going to have a tendency, especially when you're starting out, to try and learn every single thing, every single function, every single syntax, every single trick. It's almost like you're trying to learn a language by reading a dictionary from page 1 all the way to page, 1,200. But that's not how things work. As a matter of fact, when I work with different programming languages, I don't know all the syntaxes. I don't know all the methods and functions. And what a lot of developers do is not necessarily memorize everything, just like you would every single word in a dictionary. Instead, you understand what exists and what you can use, but you can always Google things. And most of the time, developers are Googling things, no matter how experienced they are. For example, if we go to the Python documentation here, we can go through everything, right? I can go through the language reference and read through everything. And this is really, really useful information. But you're not going to memorize every single thing about the language because there's a lot. This is the Python language, and then there's also the libraries, the standard libraries that we can use. And if you sit through here and just read everything in here, well, you're not going to memorize anything. In order for you to actually learn Python, you have to use the language. And you'll notice that some things are used a lot more than others. Just like in human languages, like when you learn English, there's really difficult words that don't get used that often. And there's words like and, the, or apple that get used very often. So we're going to learn the language in a way that makes sense, in a way that's efficient, where we focus on the 20% that gets used 80% of the time. And all these smaller, more complicated things we're going to cover, but we're not going to cover one by one from start to finish. We're going to jump around. The idea being that when you learn a programming language, you're just using these concepts and slowly you're learning what's out there so that when you have a problem, you can identify it and remember, oh, I think Python has a pathlib library that I can use. Or perhaps remember that, oh, I can use tuples in Python. So your first developer fundamental is this. Don't learn a language as if you're trying to get 100% on a test. We're going to learn a language by actually using it, focusing on the things that actually matter. All right, that's enough talking for me. I'll see you in the next video. Bye-bye. Welcome back. Let's talk about an important term when it comes to programming, and that is operator precedence. Now, what does that mean? Again, we're using our knowledge from math class. It's the idea that if I do 20 plus 3 times 4, it means that different operators have precedence over different ones. That is, we multiply this first, equals to 12, and then 20 gets added to 12. Because the Python interpreter is going to follow a basic set of rules. For example, if I do 20 minus 3 here, and let's print this out, click run, I get 8. Because 3 times 4 gets evaluated first, which equals to 12, and then subtracted from 20. It's not that this goes first and then we multiply 17 by 4. And this operator precedence shouldn't be new, right? If you've taken any sort of math class, you understand that this is how, math works. And this works the same in all programming languages. So the order is this. First, we follow the brackets. So whatever is wrapped in a bracket, we do first. The second is we do the power of. So whatever is done in the power of will be after parentheses. For example, if I do parentheses here, and then to the power of, let's say, 2, or let's do plus 2 to the power of 2. Well, the first operation that will happen is 20 minus 3, because that's the first precedence. And then we do 2 to the power of 2, because that's the next precedence. And then only after we do that, we add these two together. If I click run, I get 21, which again makes sense. 17 plus 4. After the power of, we have the multiplication and division. And then finally, the last precedence is addition and subtraction. Now, this isn't going to be a math class. Some people really love math. Some people really don't. But I want to just give you this basic understanding of operator precedence when you see it. We'll do some exercises here to get accustomed to it, but trust me, this is as mathy as we're going to get in this course. The math part of the course is, well, just here. It's going to get a lot more interesting as we learn about different data types. I'll see you in the next one. Bye-bye. Welcome back. This is a quick optional video that, well, with something that you probably won't use, but I want you to just know that it's out there. And that is, there's actually an extra data type that I didn't talk about, and it's called complex. And as the name suggests, it's pretty complex. However, a complex number, again, is a number that is a third type. Instead of int and float, we also have this type for numbers. Now, the reason I'm not really teaching complex is that you only use this if you're doing something really, really complex math. Most of the time, you'll never use it. I personally have never used it, but it is good to know that it exists. It's the equivalent to a real number, and you can read about complex numbers if you want. But again, that's something that you don't need to worry 99.9% of the time. Another thing I want to talk to you about is this idea that these integers and floats get stored, such as 5, in memory as binary. That is, as binary numbers, ones and zeros. And there's actually an action or function that we can use in Python called bin for binary. And you can see that a bin returns the binary representation of an integer. So it's going to return whatever the binary version of 5 is. If I click run here, well, I have to print, remember. So let's print and click run, and I get the binary representation. Now, instead of all zeros and ones, there's also this idea of b. And that is what Python uses underneath the hood to say, hey, when I see this number with 0b, that's a binary number. But if I Google binary number 5, I see that the binary number for 5 is 101, which, again, that's what we see here. So that's really cool, really interesting just to know that it exists. By the way, just for fun, let's say that we want to return this into a decimal. Let's say we're the computer and we just retrieve this binary number. I can do int and then wrap this like this in single or double quotes. And then with the int, I can also say, hey, I want this return to a number that is base 10, which is what us humans use. So if I actually do print here and click run, well, actually we have to do base 2 here, right? Because what we're saying is, hey, this number is base 2 and convert it to integer. And base 2 number is, well, zeros and 1. It's a binary number. So if I click run here, look at that. I get 5. So in your head, you can think of it this way. When we store a number like 5, an integer like 5, when a computer retrieves that number, let's say we're doing some addition, well, it's going to grab this from memory. It's going to say, well, this is a binary number, and I'm going to convert it into integer. very, very cool. Now, the reason I taught this here, you won't see this a lot in beginner courses, and especially so early in the course, but I think it's an important principle. Although you might not get tested on this ever, for you to just understand how things are working underneath the hood, I believe is an important thing for you to do in order to become a great developer. So hopefully this doesn't confuse you too much. I'll see you in the next video. Bye-bye. Welcome back. So we've just learned about the first two, well, kind of three, because we also mentioned that there is such a thing as a complex number in Python. But we talked about the main ones, the int and float, and there are still a few data types remaining. But before we get to these, we are missing an important concept. And this is going to be our first important term in Python, and as a matter of fact, in all programming languages. It's called variables. Yep, that's a term. Now, if this is your first time learning a programming language, you might not know what this means. If this isn't your first time, well, this is very simple because all languages have variables. But what are they exactly? Well, variables store information that can be used in our programs. So we can hold perhaps user inputs like values. Maybe when you log into Facebook, you need to hold some information such as your profile picture, or maybe your date of birth in a variable. Variables are ways for us to store information on our computer. So let's have a look at this. If we remove this, and let's say I'm creating a quiz program. And this quiz program maybe measures your IQ. And let's say you just took the quiz and you found out that your IQ is 190. Quite high, good job. But we need to store that information somewhere. Well, we can do that with variables. So that in Python, all we need to do is name it whatever we want. In our case, it'll be IQ. And we're going to say IQ equals 190. And this IQ here is a variable. It is something that I just completely made up. I could name it whatever I want. That's a variable too. The idea is that once we assign to a variable, that is, we're saying 190 is going to be assigned to IQ, I can now use it in my program whenever I want. For example, I can later on print, or make sure it's not cap, let's do print IQ. And if I do that and click run, you see that I can use IQ. So we can pretend here that a user takes a quiz, finds out their IQ is 190. We can store that information in this variable, and later on, when they come perhaps online or try to use the program again, they don't have to take the quiz all over because, well, we've stored that information in IQ. And remember what I said at the beginning. Programs are simply data that's being stored, that's being changed, that's being removed, and that's all programs are. And variables are important concepts in Python and all languages. Now, variables can also sometimes be called names. So this could be a name, for example. And assigning a value is also known as binding. That is, we're binding the value 190 to this variable so that when we request this variable later on in our program, our computer knows how to look for this information. It's going to say, hey, I know what IQ is. I stored it somewhere in memory. And it's going to go look for that. And because it's being bound to a value, it points to this value 190. And remember, this number in memory gets stored as a binary representation in zeros and ones, right? But it doesn't matter to us because however our machine stores it, we don't care. We just want to be able to retrieve it. And then when we print it to do, well, get 190. Now, we're going to be using variables all over the course. But on top of just naming variables however we want, there's some best practices around variables of how you should write good variables. And as a matter of fact, these are specific rules that the Python community as a whole has that you'll just have to remember. So let's have a look at this. Variables, and remember, this is the symbol for best practices, are what we call snake case. Snake case means it's all lowercase and then spaces, well, they don't exist. We use underscores. Variables must start with a lowercase or an underscore. Variables can be anything with letters, numbers, and underscores. But remember, they have to start with lowercase and underscore. That means we can't start a variable with a number. They're also case sensitive. That means if I create a variable, but let's say this snake case, this variable has a capital E instead of a lowercase e, that'll be a different variable. And then finally, you can't overwrite keywords. Let's go through these with some examples. First, a variable has to be in the form of a snake case. That is, if I want to call this user IQ, I should technically have an underscore here instead of a space, just to make sure that a programmer, maybe I'm working on a team, can read this variable. So that's snake case. You also have to start your variables with either a letter or an underscore. So I can technically do this. And I click run. Well, that's going to give me an error because I've changed the variable. So now in order to access that variable, you have to go like this. Now, underscore in Python signifies a private variable, something that we'll go over later on in the course. But usually you're starting your variables with a letter. And afterwards, yeah, you can add numbers if you want in here. That's no problem. This is still going to work. This is a valid variable. Finally, a variable is case sensitive. So if I do user IQ here, and I do capital letters, I can't access this like this because, well, it doesn't exist. Again, it's case sensitive. We have to make sure that we match. And finally, we don't want to overwrite keywords. What does that mean? Keywords in Python, well, they already mean something in Python. For example, this print is a keyword. You can see it highlighted in blue. So that if I create a variable saying print equals 190, and then I do print, let's see what happens. We get an error because I can't really assign to this variable because print already means something. Now I know what you're wondering. What are these keywords in Python? That's a simple Google search away. And we'll learn these throughout our course. If we go to Python keywords by WE3 Schools, you'll see that we have these keywords that each mean something in Python. Again, we'll go through these and we'll learn them throughout our course. And if you look, it's not that intimidating. There's not that many. So as we practice, you'll start to get familiar with them. But the easiest way to tell whether it's keyword or an important word in Python, well, you see that it's highlighted in blue. As soon as you create a variable that is unique, it's highlighted in white. And this will be the case with whatever environment that you're typing code into, as long as it's set up for Python. Now, beyond the Python keywords, there are different things like, for example, the int for integer that we've learned. So these we're going to get familiar with. So a good rule of thumb for variables is to make them really descriptive. Really say what your intention is. And a good programmer is somebody that's able to name things really well with their variables. So if a new developer comes and looks at your code, it's easily understood. Finally, variables can also be reassigned. For example, let's say we have IQ here of 190, and then I decide to perhaps have another variable, call it user age. And for some reason, I want to assign user age to perhaps have IQ divided by 4. Is that going to work? It should, right? I'm saying user age is going to equal 47.5. I'm using IQ, which is 190, dividing it by 4, and then assigning it to user age. I can maybe assign this to another variable, called user age or called A. And once again, I run this and it's printing the same thing. So you can use variables to store that information and use it whenever you want. You can use it in operations, you can use it to reassign it, whatever your program needs. Now, later on in the course, we're going to learn about classes, and classes actually have a different convention than this, but we'll get to that later on. For now though, I want to mention two small gotchas with variables that you should be careful with. For example, there's an idea of constants. And constants are those things that never change in a program. For example, if we wanted to create a constant, such as the value of pi, let's say for now it's 3.14, we can have it all in capitals. And that's going to tell other programmers that, hey, this is a constant. This number is not meant to change. I mean, we could change it if we want. There you go. I just made pi equal to 0. So it was stored as 3.14 in memory, but then we overrode it and reassigned it the value of 0. You can still do that, but a good convention is that if you see this, that means this number or this value should never be changed. Another type of variable that you're going to see, and this is something we'll see later on in the course, are it doesn't look like I just did double underscores here, but it's 2 underscores, and we call these dunder. And as you can see here, we have some dunder variables that Python has. Now, we'll learn more about these later on, but the idea here is that these are meant to be left alone. You should not touch them. You shouldn't create a variable with 2 underscores like this and call it hi and assign it a value. I mean, you still can, however, this is generally not good practice. So you want to be careful with that. But the one thing that I really want you to take away from this is that variables are really important concepts in programming. Naming variables is one of the most important skills you have as a programmer. I know it sounds silly, but there's so many times that I read code that is so hard to understand simply because a programmer is not descriptive enough. So throughout the course, we're going to learn how to name things well so that our code reads like English. And that's the whole point of writing good code. The point of writing good code is that it's readable and understandable by other programmers. By the way, to finish off, I just want to show you one quick trick. There's also a way that you might see in some code bases that uses something like this. Equals 1, 2, 3. And this simply is a way for us to rapidly assign values to variables multiple times. So for example, if I do print A, then print B, then print C, and I run this, you see that I get 1, 2, 3. We assign value of 1 to A, value of 2 to B, and value of 3 to C. Just a quick shorthand way that you might encounter. All right, let's take a break, and I'll see you in the next one. Let's learn another important key term. Well, 2 for that matter. One is expressions, and the other one is statements. You're going to hear this a lot when talking to programmers. So what do they mean? Let's have a look. If we create a piece of code here, let's just say IQ is 100. IQ has lowered. And then let's say user age is going to equal IQ divided by 5. An expression is this part of the code. It's a piece of code that produces a value. In our case, this produces a value, right? Because 100 divided by 5 is going to equal 20. So this is an expression. A statement, on the other hand, is an entire line of code. Not this entire thing, but an entire line of code that performs some sort of action. In this case, what action are we performing? Well, the action is that we're calculating 100 divided by 5 and then assigning that value to the variable user age. So This is an expression. This is a statement. And also this is another statement. So if you hear me mentioning these terms throughout the course, hopefully now you know what they mean. I'll see you in the next one. Bye-bye. Welcome back. I want to quickly talk about something called augmented assignment operator. So we've learned that we can create variables like some value, and we can assign it a data type. In our case, let's just assign it 5. There's something called augmented assignment operator that allows us to do something quite neat. Let's have a look. So if this value, I want to increase it, let's say 5 plus 2, so add 2 to it, I could do that. Or I could even use some value which is already 5 by the time it gets to line 3 and do something like this. If I print some value and I click run, I'll get 7 because 5 plus 2 equals to 7. So in memory, some value points to 7. But there's a neater way of doing this called augmented assignment operator. Instead of doing something like this, I could just simply add a plus to the equals. So we're going to say some value plus equals 2 is still going to equal 7. So it's the same thing as before. And this is called augmented assignment operator. It's a shorthand of us doing something like this. We can also change this to something like minus, which once again is like subtracting 2 from whatever the previous value of some value was. Now, if I was to do this at the beginning here, so let's just do here and then comment this out. And if I click run, I'll get an error because some value is not defined. We haven't really created anything. So in order for this to work, we need to make sure that this variable has some previous value. So we've learned about the plus, the minus, and then finally we have the multiply. Once again, if I run this, we get 10. Remember, this is just the same as us saying some value times 2. It's just a shorthand form. All right, this was a quick video in case you see something like this in the wild. Now, you shouldn't be afraid. Remember that the operator comes to the left of the equal sign. I'll see you in the next one. Bye-bye. All right, we're almost kind of flying through this. I know we're going slow here, but trust me, once you get these data types, things become a lot easier. So we're just climbing that mountain so that we can start looking at a higher level at the language of Python. To keep going, let's talk about this data type, str, which stands for strings. Let's see what they are. A string is simply, well, a piece of text. For example, a string can be written with quotation marks. And I can say, hi, hello there. And that is a string. You see that the color changed here in my editor. I can also make strings with double quotes. So once again, this is also a valid string. And I can put anything I want in here. I can do numbers if I wanted to, exclamation marks. It's just a piece of text. You can think of it as a sentence for now. And if I do the type function here, remember, these brackets denote that we want to perform some sort of action, which is we're using the type action that Python gives us. And if I click run, you see that, and remember we have to print it out as well. So let's do print so that we can see the display. And I click run, you see that it's str. It's a type of string. And now we can use this in important ways. For example, imagine you're creating a login form and we want to collect somebody's username and password. Well, we can have username variable that we assign, let's say, some sort of username. Let's call it supercoder. And then password can be super secret. And now we have these variables, usernames and passwords, that we can use throughout our program, such as to check if a password exists. And remember, I can use single quotes or double quotes. But there's a third way that we can write strings in Python. And this, well, is used for long strings. So let's just create a variable long string. And what we can do here is 3 single quotes in a row, like this. And then here, I can just say, wow, maybe a pair of eyes of somebody that's really impressed, and let's go with a mouth. That actually kind of looks like hair. All right, and then I finish it off with 3 single quotes again. So now if I print the long string and I click run, look at that. My little weird emoji face is printed. So the 3 single quotes is for long strings that I can keep going on multiple lines. For example, I can't do this with the single quote. You see that the orange color is now gone because Python is going to say this is a new line and this is another line. And it's going to give me an error because, well, a cret with a quote doesn't mean anything. But if we use 3 single quotes, you can see that we can do multi-line strings. And this is really useful if you want to have maybe long sentences and paragraphs. Now, with a string, we can do some cool things that we saw in the numbers videos. What if I had something like this? Let's say I wanted to grab the first name of a user. Just give my own name here, and then last name. And again, my super hard to pronounce last name. Could we do something like this, where we have full name equals to first name plus last name? And then if we print here the full name like this, should this work? Well, let's have a look. Let me remove this part over here just so we have nice and clean looking code. And if I click run, there you go. My name is printed, but you see that there's no spaces here because we're going to use the addition sign to attach Andre to Nagoye, but you can see that there's no spaces here. So I can add a space if I wanted to, or I can just simply create another string inside of here, just like this, and then add a space in between. So we're just using the plus sign, which we've seen in the numbers videos, but instead to add strings together. And now if I click run, you see that I got the space because I'm adding a space in here, in between the names. Very, very cool. But there's a few more neat things that we can do with strings. So let's take a break, and I'll see you in the next video. Welcome back. I want to quickly touch on the subject of what we call string concatenation. Yes, programmers love creating really complex names when concepts may not be as complex. So what does string concatenation mean? Well, it simply means adding strings together. So I can do hello plus Andre, and I've concatenated the string. I've added 2 strings together. So if I print this, I get hello Andre. So if you ever hear people talk about string concatenation, that's what they mean. We're concatenating strings. By the way, what do you think will happen if I do hello plus 5? If I click run, that's not good, is it? I get type error. Must be string, not int. So it looks like string concatenation only works with strings. We'll explore that a little bit more in the next video. Welcome back. Remember in Python that string is written as str, and this is a special word. Actually, it's a built-in, what we call function, or built-in action that we can take. Now, let me ask you this. What happens if I do string 100? 100 is clearly a number, an integer. But what if we run the string function on this? Let's find out. Let's do print here, and then run this. If I click run, I get 100. All right, but is this an int or a string? To find that out, once again, let's wrap this, so the answer of whatever this value is, into type, like so. I know this is a lot of brackets, but remember, we're evaluating this piece of code, so we're turning 100 into a string, or running the string action, and then we're going to check the type of this entire thing, and then we're going to print it out. If I click run, I see that it's a string type. So we've converted 100 into string using this. Now, just to confuse you a little bit more, what if we do something like int? Like this. All right, even more brackets. What happens now? Can you guess? Well, we convert 100 into a string, then convert it back into an integer, and then we check the type of it, which is a class int, and then we print that. So remember, this was the same as me saying a equals str 100, and then b is going to equal int of a, because we're evaluating this part, and then I'm saying c is going to equal the type of whatever b is, and then finally we're printing c. So that piece of code was the same as doing this. Very, very cool. Now, this is the idea of type conversion. Again, if I were to write that down, it's called type conversion. We're converting the type of our data types. And you can do that throughout programming. And we'll talk a lot about this throughout the course. But it's the main reason we have things like str, int, we have things like float, and many other data types that we're going to talk about. I'll see you in the next video. Bye-bye. Welcome back. Let's talk about something called escape sequence in Python. Let's comment this out. And let me ask you a question. What if we wanted to have a string that tells me, let's say, the weather? And here we want to write, it's sunny. You see how the highlighting changed here? Because I want to say it's with an apostrophe s. But Python is reading this and saying, okay, this is the start of the string and this is the end of the string. And then I have no idea what this is, and then we're starting a string again. How can we fix this? Well, we can add a double quote string instead, and this now works. But what if, for some reason, we also wanted to add it's kind of sunny in quotation marks? Well, now we have another issue. So how can we solve this? Because in human language, we have double quotes and apostrophes. Well, we can use escape sequences here. And this is a little hard to understand at first, but it's simply adding a slash like this. So the one right above your enter on the keyboard. So this slash, when Python goes through it, is going to say, all right, whatever comes after this, I recognize this symbol. Whatever comes after this, I'm going to assume it's a string. So now if I do backslash here, and then backslash here, it's going to say, hey, Python, I'm letting you know whatever comes after this, it's a string. I'm letting you know whatever comes after this is a string. And then I'm letting you know what comes after this is a string. So that when we print the weather, everything is printed nicely. Awesome. Now, this escape sequence can be used in multiple ways. For example, if I want to have an actual backslash, well, I can go like this. And because it's saying whatever comes after this is a string, it's going to assume that this is a string now. So if I run this, you see that we get this backslash. And there's a few other neat tricks that you can do with it. For example, one of it is the backslash T. What does that mean? Well, let's remove this for now. There you go. The backslash T, remember, well, let's add a space in here so we can distinguish it, is going to say, hey, whatever comes after this, I want you to add a tab. This is a special meaning here. So if I click on run, you see that it's added a tab spacing to my string. Another one is using n, or a new line. So let's leave T here and then add a backslash n and then say, hope you have a good day. What do you think will happen here? If I click run, I have a tab from the backslash T, and then I have a new line after kind of sunny because I do the backslash n, which denotes a new line, so that this shows up on a new line. Now, these escape sequences are hard to see at first, but they're pretty much available in all programming languages that use strings. So if you come from another language, this shouldn't be that strange to you. If it's your first time seeing this, you just need to get used to this syntax, and every once in a while, go to the Python documentation and just type in escape sequences, and you'll see all the ones that we have. These are the main ones that you need to know. All right, more to learn in the next video. Welcome back. Let's talk about the topic of formatted strings. Up until now, we've just written simple strings. But we want a program that's dynamic, that's static. Let's say we have a Amazon page, and we're working at Amazon actually. And when a user logs into their profile, well, we want to display their name or what they have in the cart. In that case, we don't want to just hard code and write every single user's name, like Andre, or another user, Joe, and write every single name in the world. No, ideally, what we can do is have something dynamic, where let's say it's a profile page and we simply use the name variable and we display that on the page. Now, this name variable should equal whatever the user's name is. And this is something that we can grab from the database, again, something that we'll talk later on in the course. But let's assume that in here, when we do equals, we're going to grab some user information, which will be the name. And this name, for now, will be John. Or let's go Johnny. And this Johnny, we want to display on the profile page. And we can do that with formatted strings. We can simply do something like print and then say name. But we also want to greet that person, right? So let's do hi and then plus name. And remember to add a space. If I click run, I get hi Johnny. But as we get more and more information, let's say we have age and Johnny is 55. If I wanted to extend the sentence and I want to say you are, and then add another plus, make sure we add a space in here, and then add year old. Run here. All right, we get a type error. Must be string, not int. Oh boy. All right, so we have to convert this into a string. So remember, we can do that like this. And then if I click run, hi Johnny, you are 55-year-old or years old. All right, that was a little cumbersome. But we're making our Amazon page dynamic. We can grab different information from the database and we'll have in a string something according to the user. But there's a better way of doing this. And with formatted strings, all we need to do is add an F at the beginning. And this F at the beginning is going to tell Python, hey, this is going to be a formatted string. And instead of doing all this plus and name and all this stuff and doing the str to convert the type, we can simply do something like this. Let's remove this and simply do brackets and say name. And then again, remove all of this and say age. So I'm going to say hi, name, you are age years old. And if I click run here, you see that it still works. This is a new feature of Python 3. By adding F to the beginning, it's saying, hey, this is going to be a formatted string. And I want you to just make these variables available as strings inside of, well, this string. How much cleaner is that? Now, although this is nice and clean, and this is my preferred way of writing strings, before Python 3, you didn't really have this. So in Python 2, and mind you, this works in Python 3 as well, as you can see, we had something different to accomplish this. What we had was this idea of a dot format. And dot format, so let's remove the F here, is going to do the same thing for us. We do a bracket here, and then we say, hey, we want Johnny and age of 55. And we can just remove these variable names. If I click run here, I get an error. And you have to be careful here. Dot format works on strings, but you can see over here that we did it outside of the brackets. And what it's doing is saying, hey, run the format action on this print. But print is not really a string, right? So you have to make sure that we move the brackets to the outside so that we evaluate this piece of code first. So the string is going to get formatted, and then we're going to print. If I run this, hi Johnny, you are 55 years old. So that works the same way. But what if we wanted to use variables? Because right now we're just doing this by order. So whatever comes first gets filled in first in the brackets. Well, we can do something like name and age. Let's see, can we do that? Let's run. There you go. That works the same way. What if we had a specific order? Maybe we want this to be age and here to be name. Well, we can mix those around. We can say 1 here and 0 here. Because in computer science, we always start counting from 0. So this is 0 and this is 1. If we had something else in here, let's say a third variable, then this will be 2. So if I click run here, all right, everything is upside down. Finally, I can just create my own variables if I wanted to. So let's say hi, let's say new name equals Sally. And then age of Sally is going to equal, let's say 100. Sally is very old. Now, if I do 0, let's say I'm 1 here, if I click run. So now we'll actually get an error. Tuple index out of range. Now we haven't really learned about tuples and ranges, and this is a little confusing, but a bit of a trick here. We want to make sure that we add now, because we've given the actual variable a value, we need to actually say new name here. And here will be age. So that if I click run, there you go. Hi, Sally. You are 100 years old. as you can see, with dot format, things are a little bit more complicated. You'll still see this, and all Python 2 code still uses the dot format. And you'll see a lot of Python 3 code bases that still use dot format because some people prefer it. But I would argue that the F at the beginning of a formatted string is the way to go because, well, it just makes things so much easier, right? Nice and clean, nice and easy. So I do recommend that you use the formatted string with the F in front. And for short, we usually call this an F string. All right, I'll see you in the next one. Bye-bye. Now, up to this point, we've learned that str is an ordered sequence of characters, right? It's essentially a piece of text where we can write our names, passwords, paragraphs, and sentences. And strings underneath the hood are stored in memory, as I said, as an ordered sequence of characters. So for example, if I had the string me, then this will be stored in our computer's memory in an order. So M will be stored in a place in memory, and after that place in memory, E will be stored, then the space will be stored, and then M, then E, then space, then M, then E. So if you think of a bookshelf, each one of these is ordered in a different part of the bookshelf, but one after another. And the way we can think about this is like this. The M is stored in location 0, and then E is stored in location 1, and then space is stored in location 2, and so on and so forth. And each shelf now corresponds to a value. So that when we ask the computer, hey, I want you to grab this string, we know that, hey, we're going to look in the shelf 0 to 7. Now, why is this important? Because one of the most useful things you can do with strings is to access different part of a string using its what we call an index. So for example, when you have a string, and let's call this variable or this piece of string selfish. And selfish has me. And I'm going to comment this out just like this. Make sure it's aligned, okay? And what I'm going to do here is I'm going to say selfish and then square brackets right here, and then type in 0. Now, if I print this and I click run, check that out. I get the letter M. Why is that? Well, using the square brackets, I'm telling the computer, hey, grab the variable selfish, and then from that variable selfish, grab whatever is an index of 0. And what's on that bookshelf of index of 0? Well, the letter M. What if I do 7? What do you think will happen? If I click run, I get E, because on the bookshelf of number 7, that's E. And when I'm getting just selfish, I get the entire string. It's going to say, all right, I'm going to grab from the bookshelf index of 0 all the way to 7. Very, very cool. And this concept we're going to explore throughout the course, and you're going to see why it's important very soon. But using this knowledge, we can do a lot of string manipulation. And Python has this unique feature that we're going to talk about right now that allows us to grab different pieces of text. So let's have a look here. The rule here is when we use square brackets in Python, the first item that we put between the square brackets is what we call the start. The start is, hey, where do you want me to look? In our case, we said we want to look at 0, so we got M. We wanted to look at 7, we got E. But then there's an extra thing that we can do. If we do a colon here, we also have the option to say, hey, where to stop. What does that mean? Well, if I do something, and you know what, let's change this to 0, 1, 2, 3, 4, 5, 6, 7, just so it's easier to understand. If I do, let's say, 0, colon, 2, and I click run, I get start at 0, end at 2. So I get to grab 0 to 1. Because remember, I'm saying start here, but then stop as soon as you get to bookshelf 2. We don't want that. So if I do 0 to 7, what do you think will happen? Well, I click run, and I get all the way to 6. So in order for us to grab the full string, we have to do 0 to 8. Because there's actually 8 characters here, right? Because we start from 0. If I click run, there you go. Now there's a third thing that we can add here. And this is called the step over. And the step over says, hey, start here, end here, and then step over a few things. So the default is 1 because we're going 1 by 1 through our bookshelf. You see that we get the entire string. But if I add 2 here, it steps over by 2. So I grab 0, then I step over 1, 2, grab 2, then step over 1, 2, grab 4, step over, and so on and so forth. So let me ask you a couple of tricky questions here. What happens if I do this? Is this valid? If I click run, what will happen? Ready to guess? I get 1, 2, 3, 4, 5, 6, 7. This says, hey, start at 1, so that is right here. But then afterwards, stop, well, there's nothing there. So the default is going to say, go all the way to the end. I know this is confusing, but hang in there. Practice this often enough, and this will become second nature. Okay, what if I do something like this, where I don't fill the start and do 5 here? What happens now? Ready? I get 0, 1, 2, 3, 4, all the way until 5. So it starts as default 0 and goes to 5. Okay, what if I do something like this? 2 semicolons and then 1. If I click run, all right, I get the default behavior. Because it's starting at 0 when there's nothing. It ends at whenever the string ends, when there's nothing, and then we're stepping over through it once. All right, but what if we do something like this? What if I do -1 here? This is a tricky one. What will happen? Let's find out. I get 7. In Python, the negative index means, hey, start at the end of the string. So that if I do -2, I get 6. If I do -3, I get 5 because I'm going backwards. And a neat trick that you can do here is if we do semicolon, semicolon, -1, and this is actually quite a common operation, so you just have to memorize this even though it looks weird. It means start, stop, there's no limit here, but I want to step over from the back. So what do you think will happen here? If I click run, do you see that? We get the reverse of the string. So this is a very useful notation if you want to, let's say, reverse an order. And if we want to, let's say, skip by 2, I click run, and you see that we're skipping by 2 now. Now, hopefully your head doesn't hurt with all this notation. You just have to get used to it. It's something quite unique to Python, but it's very, very useful. So up until now, we learned that strings can be accessed quite easily. And using the square brackets, we can access different parts of the string. And this idea of a start, a stop, And a step over is what we call slicing or string slicing, because we can slice the string however we like. But we also need to learn another important term that's going to come up again and again throughout this course. And as a matter of fact, it's an important concept that as you get more advanced into programming, you really need to understand. What is this concept? Well, it's this idea of immutability. It's an important term in programming. What does immutability mean? Well, strings in Python are immutable. That means they cannot be changed. What do I mean by that? Now that we've assigned selfish this value, this string, well, I can reassign it, right? I can say selfish is 100 now. And if I print selfish and I click run, that works. But if I instead do something like the first index of selfish is going to equal 8, and I click run, I get an error. I get a type error saying string object does not support item assignment. Why is that? Because strings are immutable. That is, I cannot change the value of this once it's created. I can't just immediately change it to 8, 1, 2, 3, 4, 5, 6, 7. No, it has to stay the same. The only way that I can remove this or change this is to completely reassign the value. So that in memory, Python removes all of this from our bookshelf of memory and instead just assigns 8 into the 0 bookshelf and removes everything else because we don't use it anymore. Now, this idea of immutability is something we'll explore more and more, especially when we start talking about lists. But for now, just remember that you can't reassign part of a string. Once created, it exists like that in that form. The only way we can change it is to create something new. We can do selfish plus 8, and we can create it that way. But now, this selfish is a whole new string. This no longer exists, and a whole new shelf space was created for us to use this whole new string. Again, if this doesn't make sense to you or why it's important just yet, don't worry. We'll get there. For now, though, I'll see you in the next video. Bye-bye. Welcome back. So far, we've learned a few built-in functions that Python has. Few built-in actions, right? Actions that we can take on data. And we learned about str, we learned about int, we learned about float, and the type conversion that we can do. We also learned about type, we also learned about print. And these built-in functions in Python, well, there's a few of them. And I'll link to this resource, but there's not too many. As a matter of fact, we've also seen ones like ABS or round in our numbers video. So numbers had some functions that we can use, some built-in functions. Well, strings also has a very useful one called len, which stands for length. So as you guessed it, if I type in something like this and I print this out and I click run, I get 9 because it's calculating the length of the string. In our case, 1, 2, 3, 4, 5, 6, 7, 8, 9. The length of the string is 9. Now you have to be careful here because the length itself doesn't start at 0 as we've seen with indexes. Instead, it counts like humans do from 1. So a neat thing to do here is I can do something like this. Let's say that we have a variable greet that equals hello. Well, I can grab the greet variable, which is a string, and use string slicing to grab, well, the first and then go all the way until the end. Now the default already does this. If I leave it like this, it's going to grab hello. Oh, and make sure I add a bracket here. Let's click run. I get hello. Now, if I do 0 to length of greet, what does that mean? Well, if I click run, I still get hello because the length of greet is 9. Like so. Now, this length function is quite useful and we're going to use it a lot in this course. But I want to introduce to you the concept of built-in functions, as well as what we call built-in methods. What does that mean? A built-in function had this syntax of the word that was highlighted in blue, and then we used curly brackets to perform some action on a data type. However, Python also has this idea of methods. And methods are similar to functions, but they are owned by something. So for example, in Python, we have string methods. So these are methods or actions that only strings can perform. And don't worry, this is something that we'll talk more about when we talk about classes and functions. But for now, Python, for example, has string methods. So these are methods that we can use specifically for strings. And methods have a special syntax, where instead of just the word with the curly brackets, it usually has a dot in front of it. So dot, and then some sort of word, and we've actually seen one, format, right? Dot format curly brackets, or brackets, is a method. And if I go to Python string methods, and I scroll down or scroll up, we see that format specific values in a string, is a method. Now, why do we care? Well, with this, Python gives us automatic tools that we can use on strings. So let's explore some of these string methods. Let's create a quote here. And the quote is going to be or not to be. Now, in here, with this quote, we can use some methods on this string. Now, I'm not going to go through everything because, well, 60% of these you're most likely never going to use in your career. I'm going to go over the important ones that you'll see over and over again, but I'll also link to this so that you can see this for yourself as a reference. Remember, as a programmer, your job is not to memorize this and read a language like you read a dictionary. Instead, is to know that this resource exists and it's for you to explore and learn as a specific problem occurs. But let's get back to the task at hand. One thing that we can do is to use the upper method. We use a dot and then type in upper and then the curly brackets. And luckily for us, our editor shows us that this actually exists because of the drop-down menu. So what happens now? If I print this and I click run, look at that. Everything gets capitalized. To be or not to be. There is also another one we can use called capitalize. What's the difference between the two? Well, if I run, you see that it capitalizes the beginning of the sentence. And by the way, your editor, or in our case our REPL, if you hover over this, it'll actually tell you what it does. It returns a capitalized version of S. So whatever is to the left of the dot. And a good editor will actually show you all the things available to you. So as soon as you press a dot, look at that. I see all these purple boxes, which are methods that are available to me for a string. And you see there's a lot of them. Now, don't worry about these double underscores, these dunder methods, because this is something that we'll talk about when we talk about classes. But you can see that you have different things that you can use. For example, you have lower. Instead of upper, it lowercases everything. What if I want to use find, for example? And find simply says, hey, does B exist in the code to be or not to be? And if I click run, well, it tells me that yes, quote.find has B and it starts at index of 3. So if I go to 0, 1, 2, and then look at that, 3. So we have find, which finds us the first occurrence of a piece of text. You also have things like replace, where I can replace whatever I give it as the first thing and then separate it to the second thing. So you can see over here, it tells me old and then comma, new. And I can replace this with me. If I click run, I get to me or not to me. So this replaces all the occurrences of B. Now, the final thing I want to point out to you is that if I print here, quote, what do you think is going to happen? I've printed here and I replaced to me, to be or not to be with to me or not to me. Quite a selfish quote. But if I print this again on the 5th line, what do you think will happen? Let's find out. Whoa. Is this what you expected? Think about why this might happen based on what we've learned. Here's the thing. Remember, strings are immutable. That is, they cannot be changed. We can overwrite them if we want, but we don't change them. We either create them or destroy them. In our case, when we do quote.replace to me or not to me, it's creating a new string. Now, we're not assigning this string to anything. So eventually after we print it, we remove it from memory. But if I do something like this, where I have quote 2 equals quote.replace, and I print quote 2, well, in our case, we're creating a whole new string. We're creating a string, but we never modify the original string because it's immutable. So that quote always stays the way it is. Until we destroy it, until we remove it, our program ends, this is going to exist. All right. Hope you're having fun. Hang in there. More to learn in the next video. All right. So up until now, we've spent forever talking about numbers and strings, and you're thinking, oh God, we have so many more to go through and my head hurts already. Well, you know what? I think you're gonna really like this one because this one's really short. And they're called booleans. And booleans in Python is bool. And bool, well, there's only 2 options. A bool can either be true or false. That's it. How awesome is that? You just learned booleans. So a boolean I can assign to, let's say, my Facebook profile. I can say Andre, or I can say name equals Andre. And make sure that we form this into a string. And then I can say, well, let's say we're creating an even better social network than Facebook. We're creating our own. And this social network also has the is cool option on your user profile. And let's say for now it's false. You see over here that's being highlighted. Now is cool is set to false. But all of a sudden I'm thinking, my profile doesn't look good if is cool is set to false. So I'm going to change that. I'm going to say is cool is now equal to true. Now my profile has been changed to is cool is true. Hooray! And that's it. Booleans represent this idea of true and false, which in programming is kind of like saying 0 and 1. They're logical values, right? There's some logic that we can use. And we'll see when we talk about conditionals in upcoming videos, where Booleans become really, really useful, because we can use Booleans to control the flow of our program, to do something if something is true, to do another thing if something is false. It's a cornerstone of computer science. And by the way, a topic we're going to explore more and more is this idea of using Booleans to denote logic. So for example, what do you think a bool of 1, converting 1 to Boolean, would do? If I print this and I click run, I get true. In Boolean, 1 means true. A 0, well, that equals false. And remember, we're just simply converting this integer into a Boolean value. And a Boolean, well, is just either false or true. Nothing else. That's it. And I can also convert a string that says true into a Boolean true. Again, this is something we're going to explore a little bit more when we talk about conditional logic. But I wanted to make this video nice and short to let you know that, hey, not all these data types are as complex as, well, numbers and strings. All right, nice and short. I'll see you in the next one. Bye-bye. Welcome back. So up until now, we've learned about integers, floats, strings, and Boolean values. So let's try and tie some of those things together. Let's imagine you were Facebook. How do you think Facebook works underneath the hood when it comes to your profile? Well, they would have, let's say, a variable called name, and this will have your name. And then they'll probably have a variable with your age, let's say 50. I'm not actually 50, but I'm pretending to be for this case, just so I sound wiser. And then let's say relationship status. So again, we also have relationship status on Facebook. And for now, let's say single. So that's my Facebook profile right there. Now, if we wanted to perhaps change that, let's say my relationship status all of a sudden goes from single to it's complicated. Well, that's an easy fix. We would just do relationship status equals to it's complicated. And remember, because of the single quote, we'll have to do backslash it's complicated. And now if I print my relationship status, you'll see that it's been updated to it's complicated. I am no longer single. Hooray! But this is pretty simple. Let's do something more complicated. And this is going to be a fun exercise. Let's create a program that guesses your age. Let's use the input method that we've seen before. Remember, the input method allows us to type something in here and receive it as input. So we can assign that to a variable. So let's say this variable is going to be birth year, and that's going to equal the input that's going to ask when or what year were you born. Now, from here, I want you to pause the video and try to solve this yourself. How can you make it so that at the end of this program, you're going to get asked, what year were you born? You're going to type in your year, and then it's going to print out your age is whatever the age is. So pause the video, try and solve this on your own. Mind you, there is a bit of a trick in here. So if you get stuck, try to Google around and figure out what the issue may be. Again, part of being a programmer is trying to solve these problems that you don't know the answers to. All right, let me show you my solution. We have our birth year here that we're going to store in a variable. And now we're going to calculate the age. I'm going to say age equals, well, it's going to equal the current year, let's say 2019, and then 2019 here is going to get subtracted from whatever the birth year that you entered. So let's enter that. And then we're simply going to say print your age is, and we want to use an F string here. So I'm going to add an F here, and then simply say age. If I run this, I get what year were you born? I was born in 1986. We get an error. And if you try this yourself, you may have encountered this error. We get something called a type error. And there's lots of errors that you can get in Python. Again, we have a section on errors, so don't stress too much about it. But if you read here, it says unsupported operand type S for minus int and string. Let's try and debug this. It looks like we're using minus on an integer and a string. So let me print out here the type of birth year. If I run this and let's enter 1986, I get class string. And this is a little gotcha, because what input does is it asks you for an input. But that input that I wrote, 1986, well, that actually gets converted to a string and assigned to birth year. So what that means is that we're trying to subtract a number or a string from a number. So how do we solve this issue? Well, you'd have to turn this into an integer. And this is something that we saw previously. What we need to do is to convert this into an integer with using the int function. So let's try that. If I remove this and click run, I'll say 1986. And look at that. Your age is 33. We've created a program that was able to tell your age based on the year that you were born. Now, this may have been tricky to you, but it teaches an important concept in programming. That is, sometimes you're storing data into different data types. And sometimes you need those different data types to interact together. So you'll see a lot of problems where you have to convert a data type. And this is a very common one where you take an input that's a string and then you convert it to something like an integer. So you can perform a mathematical operation. And that's why, if you remember, we gave you a list of all our data types in Python, the fundamental data types, and all of them were blue because, well, each one of these are actions, are functions that we can use. For example, I converted the birth year into integer, but I could have also converted this to a float, for example. And if I run this, it would still work because Python knows that, well, we can use integers and floats in mathematical operation, but you can see here that it's converted into a float now. If we convert this into a Boolean, and I click run, your age is 2018. That's really confusing, right? Well, that's because this gets turned into true, and underneath the hood, Python does something weird, where a true value is converted to 1. Because Boolean, remember, it's 1 or 0, true or false. All right, hopefully this didn't confuse you too much. It's something that we'll encounter throughout the course, so don't worry, we'll get more and more practice. However, I hope you get to practice this a little bit to really understand what's going on, because although this is a couple of lines of code, the principles that we use here, we're going to use throughout bigger and bigger code bases. So I guess I'll see you in the next one. Bye-bye. Let's talk about another developer fundamental. And this one is commenting your code. Up until now, you may have seen me add comments to our scripts. For example, right here, I added a comment of booleans. And this tells the Python interpreter, hey, this is a comment, don't run this, it's just for me, you can just ignore it and skip over to line 2. And you saw that I simply did that in Python with the pound sign. As soon as Python sees a pound sign, it adds a comment. And you can do that after a line as well. I can say, this assigns to a variable. And although this may look like 2 lines, it's actually just the word wrapping that's happening. And you can see that the interpreter just completely ignores these comments. Now, commenting sounds very, very simple, but it's an important concept. And if you want to be a good programmer, in all languages, we have commenting. But there's good ways and bad ways of commenting. And this is something that comes with practice. But here are some key guidelines. When you're commenting your code, the idea is that you're adding valuable comments. That is, if I add a comment here that says, hey, this is assign name variable a value of Andre string. A comment like this is not really good. Why is that? Well, because your code should be self-explanatory, right? The idea is for us to write code that is easy to read, easy to understand. It's not trying to be clever. Instead, it should read like English. And any Python programmer would know that here we're just simply adding Andre as a value of name. We're assigning a variable. And adding a comment like this that's self-explanatory just adds clutter to your code. So there's a trade-off here. It's good to comment your code for, let's say, if you're working on teams and other developers come and they want to understand your code. But you have to remember this principle of code being easy to read. The only time you want to add comments to your code is, well, when something really, really important is happening, where it might be a little complex. You first decide, hey, is this code written in a way that makes sense? For example, if this was variable A and this was variable B, well, this might be really hard for somebody to understand. So you might say that this is cool flag. But before you add that comment, you want to say to yourself, maybe my code is hard to read. Maybe I should just change the variable to is cool to make it more understandable. Now, this is something that you improve upon more and more. And you do want to use comments as an extra tool to make your code understandable. Maybe you write code that 6 months from now, you want to go back to understand what you did. But remember, more comments doesn't necessarily mean better code. You want to be concise and keeping things simple, while adding comments only when necessary to help others understand your code, not trying to make your unreadable code more readable. We'll explore this topic and give you advice on it throughout the course. But remember this key developer fundamental, because you're going to need it throughout your career. By the way, this article over here has some really important points that I think you'll really benefit from, especially in the commenting best practices. You can read some of the do's and don'ts and what some of the top programmers do when commenting. I know it sounds silly, but it is an important concept that most courses overlook. So I highly recommend you read over this. I'll link to it in the resources, and I'll see you in the next video. Welcome back. Let's try and do an exercise to tie everything that we've learned up until now together. We're going to create a password checker. Now, what we want to do is to create some sort of an input that we're going to ask. So we're going to use the input function. And here we're going to ask for a username. Then we're going to ask for another input. it's going to be the password. And then at the end, with the input, we want to print something the lines of password, and then we'll have maybe the actual password in here, and it will say is another variable here, long. So what we want to do is the password, and then maybe the password length, so that, let's say we printed our username, JJ, and then we give it a password of secret. Well, we should print the password secret is 1, 2, 3, 4, 5, 6 letters long. Now, obviously, we don't want to show or display the password, maybe for security reasons. So we want to convert this secret to 1, 2, 3, 4, 5, 6, 2 stars. So your task is to convert these two inputs. And you know what? Let's also do a greeting where we say the username here. So we're going to say, hey, JJ, your password, which will be marked in a star, is 6 letters long. Now, one neat trick here that you haven't learned yet and you might want to use here is this that you can do with strings. I can go star times, make sure that the star is a string, multiply it by 10, and if I print this out, I get 10 stars. So you may want to use this functionality when we're doing this. All right, pause the video, give it a go if you can. Remember, the goal is to print the username and have the password blocked with how many characters the password is. All right, pause the video. If not, I'm going to get going with the answer. So the first thing we're going to try and do is I'm going to create two inputs. So the first one, I'm going to get the username. I'm going to assign it to the variable username. And it's going to say, what is your username? Then the second one will be the password. And the password, well, we'll say, what is your password? And although this is a simple example, this is something that you will see with other big websites like Instagram or maybe Netflix when you're logging in. So now that I've stored this information into a variable, I can use it, right? I can print, and we'll do an F string to make our lives easier. So I've added the F here. And what we'll do is this. We'll say username, your password, and we'll add the password here, is, and then we'll add another variable here, which is the password length. So how are we going to calculate that? Well, let's try something here. Let's see if I can use the length function and in here do password. Let's see what happens here. What is my username? Let's go with Andre. What is my password? Let's just type in secret here. And I get, Andre, your password? Well, I can't speak English properly. My password, secret, is 6, well, 6 what? Let's write 6 letters long. Awesome. So this is working because with an F string, I can create or add a Python expression in here using the length password. But there's an issue here, right? We don't want to actually print out secret. We want to print it out in the star form. And this is a good discussion topic on readability of your code. Now, this is a simple example, but we can make this code a little bit cleaner. For example, we can break things down so that we'll have password length will be length password. So we're calculating the length. So this is going to store 6 or whatever the input of our password is. And it's nice and descriptive. It's easy for other developers to understand. And then in here, I can also have hidden password. And this hidden password will be the password length. And we're going to use that star string and multiply it by the password length. Let's make this a little bit bigger. So that now our code can be understood, well, in an easier fashion. So we have the password length. So we're going to say username, your password, but we want to make sure that it's the hidden password. So we'll copy this over here. So username, your password, we're going to print out hidden password is, and then we're going to copy password length. Now, I argue that this reads better because each line is doing something simple, and then finally, we're printing the output. And although this is a small, simple example, this idea of readability and making and writing code that makes sense is an important concept. So let's see if this works. I'm going to click run. My username, Andre. This time around, my password is going to be super secret. And look at that. Andre, your password is 11 letters long. Good job getting this far. Hopefully you got that. I'll see you in the next video. Welcome back. Let's talk about our next data type. And it's a big one, a very, very useful one. It's called list. And list is an ordered sequence of objects that can be of any type. So you can think of them as strings, right? We had strings previously that we learned about, except that each sequence of this string, well, was a string, was a letter or a number wrapped in quotation marks. Lists, on the other hand, looks something like this. Let's say we create a variable, li, and lists we denote with square brackets. And inside of these square brackets, we can have different objects. So for example, we can have 1, 2, 3, 4, 5. We can also have, let's say, li2, and this is going to have a B, C, and it can have any collection of items that we want. We can even mix and match and say that we have 1, 2, then A, then maybe even the Boolean value true. So all of these are lists. Now, lists are extremely important. And in other programming languages, you might have heard the word arrays. So in Python, lists are a form of array. And later on, when we get into the modules section of the course, we will talk about the difference between lists and arrays. But if you are coming from a different programming background, then lists are like arrays in your language, a collection of items. Now, the neat thing about lists is that it's the first data structure that we're learning. Now, what is a data structure? Data structure is a very important concept in programming languages. It's a way for us to organize information and data into, let's say, a folder or a cupboard or a box, so that these data structures can be used with different pros and cons. For example, you have a fridge where you store your food. And fridges are really, really good at putting your food inside, keeping it cold, and then taking it out. Or you might have a backpack. A backpack is really, really good to stuff everything in there, but when you're looking for things in a backpack, it's really, really hard. So you can think of data structures similar to that. A container around your data that has different pros and cons of accessing that data, removing that data, writing data. But that's something we'll get into a little bit later. The key here is that these square brackets allow us to contain information and data like strings, integers, floats if we want to, booleans, into a contained fashion. So let's think of a good example here. What if we had a shopping cart? Let's say we're Amazon here. And then Amazon has the Amazon shopping cart. And in here, we can collect different things that we want. Maybe we collect some, I don't know, notebooks. And you know what? Let's get some gadgets. Let's get some, maybe some sunglasses. We can add different items here, different strings, different data into this cart. And now, just like we saw in strings, we can access the Amazon cart in different ways. For example, I can access it, again, with square brackets, and simply say I want item 0. So if I print here and do Amazon cart, look at that, I get notebooks. The second item, I get sunglasses. What about the third item? Nope, list index out of range. But this should make sense now. This is a list where we're accessing the index of, but it only contains 2 items. So if we're going 0, 1, 2, the third item, nothing exists. So our program says, that doesn't work. You're doing something wrong. And just like strings, these list items are in memory, in their separate bookshelf, right? But one right next to each other. So we can go 0, 1, 2, 3, 4, 5, so on and so forth until the list ends. All right, let's learn about lists a lot more in the next video. Bye-bye. Welcome back. Let's continue with lists. Now, so far, these square brackets, we've seen them before, right? We saw them when working with strings. And just like strings, lists are quite similar in that we can use list slicing. If you remember, with string slicing, we had things like hello, and we were able to assign it to a string, let's say a variable string, and we could do string and then slice. So do something like this, where we had the start, the stop, and then the step through. So that we start at index of 0 and end at index of 2, and then go one by one. So list slicing is also available to us. So let's make this cart a little bit bigger. And you can actually just make things cleaner by formatting it this way. All right, so what should we add to our cart? We'll also add some toys. And then, you know what? Amazon does groceries now, so let's add some delicious grapes. Awesome. Now, let's say I wanted to get every single item in the cart. Well, we just simply do this, and we have our entire list. But let's use some list slicing. Let's say I wanted to grab from the first item to the second item. If I click run, I get notebooks and sunglasses. Maybe I want to go all the way till the end, but skip every second one. I get notebooks and toys. We start at 0, we step over to toys, and we step over and we're done. Awesome. And this is something that we've already seen when talking with strings. Okay, but here is where it gets interesting. Remember how I said that strings are immutable? That means we can't change them, right? And we talked about this. When we had a string like hello, I couldn't do greet 0 equals to, let's say, z. I'd get an error here. I get str object does not support item assignment. It's immutable. But the interesting thing with lists is that they are mutable. So that if I change my Amazon cart and say that, you know what, I don't really want notebooks. So I'm going to grab the first item, which is notebooks. And instead of notebooks, what do we want? We'll say we want a new laptop. It's a big upgrade. When I print this Amazon cart, Look at that. I'm able to change this list. And it didn't give me an error. In that sense, lists are mutable. We simply replace on the memory bookshelf of our computer notebooks, and I say, hey, change it to laptop. And they let us do that. Okay, so that's awesome. But let's try something here. What if I create another print here? And in the Amazon cart, I'll use list slicing. So let's say I want item from index of 1 all the way until index of 3. Let's run this and see what happens. Try and guess. Is that what you expected? Let's go through this code. When we get to line 10, we grab the Amazon cart, which has been updated with laptop, and I grab item 1 to 3. So that is sunglasses to toys. So 0, 1, 2, and then we stop at 3. Just to make this easier to understand, let's start off with 0 here, so that we see that laptop has been changed. And then here, in the second one, on line 11, we print the Amazon cart. But hold on a second. This list did not change. And that is because with list slicing, we're creating a new list, a new copy of this list. So here we're creating an entirely new list so that I could actually assign it to a variable. New cart is going to be Amazon cart. And let's just do the same thing here. And new cart is an entirely new list on its own. I could change new cart, let's say 0 into, let's say, gum. And if I print this, you see that I have 2 new separate lists. But a list is mutable because I can change whatever is at the index anytime I want. And every time we do list slicing, we create a new copy of that list. But I have a tricky question for you here. What happens if I just do this? If I run this? Did you see that? Instead of slicing my list, I simply said that new cart is going to equal the Amazon cart. And I changed the new cart, index of 0, to equal to gum. But now my Amazon cart got modified as well. Why is that? And this is a bit of a tricky question that you might encounter in an interview. The reason is that right now, the way that I did equals means that, hey, new cart is going to equal Amazon cart. And what does Amazon cart equal to? Well, Amazon cart points somewhere in memory in our machines that says, hey, this is what Amazon cart is. So because here we're not copying the list, instead we're just saying, hey, the value of new cart is whatever is in the memory of Amazon cart. We now, when we modify new cart, are simply changing the Amazon cart all the way back from here. So this is an important concept. If you want to, let's say, copy a list, then you do something like this, where you copy the entire list, and this is something that you'll see a lot in code bases. But this line is saying, hey, I want to create a copy, use list slicing to copy this Amazon cart, and it's going to equal new cart. So that now, if I run this, you'll see that the original Amazon cart stays the same, but the new cart is now something different. This is a quick gotcha that you just have to get used to, but it's an important concept. This idea of copying versus modifying the list. And it's something we'll explore a little bit more in the next couple of videos. For now, take a break, and I'll see you in the next one. Bye-bye. Welcome back. I want to talk to you quickly about something called matrix. And a matrix is a way to describe 2D lists, or multi-dimensional lists. What do I mean? Well, I can create a matrix, and this is a name that I just made, so I can call it whatever I want. But usually these are called matrix in programming. And it looks something like this. It's an array with another array inside of it. So let's say, for example, I have 1, 2, 3 here, and then another array, 1, or let's do 2, 4, 6, and then another array, 7, 8, 9. What's happening here? Well, it's a two-dimensional array. We have the main array, and then we have sub-arrays. 3 arrays to be exact. Now, why is this useful? And by the way, this is two-dimensional, but we can have multiple ones. For example, we can have another array inside of this array. But why is this important? These type of matrices come up a lot in topics like machine learning or image processing. For example, a computer doesn't really know what a photo of a dog is. The only thing it understands is zeros and ones. So a lot of photos, for example, let's say we had a very simple photograph of a giant X, maybe this letter X. Well, a computer can understand an image based on pixels on the screen. So maybe we can have 0, 1, 0, 1, 0, 0, or sorry, 1 here, 0 here, and then 1. And right now, a computer can look at this. And if this represented, let's say, a tiny little pixel here, or maybe a pixel here on my screen, the computer is going to say, oh, there's a 1 here, so that means I should make this green in this corner, then dark here, then green, then dark, green, dark, green, dark, green. And a computer is able to draw, let's say, an X. And this is a simple example. And using matrices, we can do a lot of these heavy calculations. And that's how computers work underneath the hood when, let's say, for example, it's trying to display something. But the reason I wanted to talk about this here is when you want to access a multi-dimensional list, well, you would do something like this. Let's say matrix, access the first item in the matrix, which in this case will be this first array because it's the first item. And then let's say we want to access the 0 in here, or let's change this to 5. Well, I'll do square brackets again and just do 0, 1. So if I go 1 here, and let's print that out. And I click run, I get 5. So it's accessing the first item in the array. So it's going to look at the first outer array, grab the first item, which is right here, and then grab the second item in that array. So 0, 1, which is 5. And you can keep doing this. If you had multi-dimensional arrays, you can keep adding, keep adding, keep adding to access that information from an array or list. But remember, in Python, we want to use the term list. I'll see you in the next one. Bye-bye. All right, let's learn about some actions that we can take on lists. And this is very exciting because you can perform a lot of actions on lists. Now, we've learned about built-in functions, right? Functions that come with Python. And we've actually seen this one before when we talked about strings, which is the length function. And here we can have it calculate the length of a list. So for example, if we had a basket here that had 1, 2, 3, 4, 5. Well, this basket, if I calculate the length of the basket, let's do print here so we can see the result. And I click run, I get 5. The length of the basket is 5 because, well, there's 5 items. Remember, a length is the actual length. It doesn't start counting from 0. It's going to do human length, which is 5. But lists get really powerful when it comes to methods. So instead of a built-in function, remember a method is an action that's owned by something and is specific, let's say, to a data type. So if we go to list methods, you'll see that Python has a few list methods that we can use. And the way we use these methods is, remember, we just add a dot after a list. So let's have a look at some of them. First, I'm going to start off with the adding ones. So let's say in this basket, we want to add something to it, to the end of the list. Well, we can use the append, and remember with a method, as soon as you write the dot, it'll tell you what we can use, which is very, very useful when you have an editor. So the first one is append. And if I hover over this, well, it just tells me appends an object to end. And in Python, an object is, well, everything in Python is an object. A number is an object, a list is an object. So just think of it as an item for now. So if I want to append, let's say 100 to the end of the list, and you know what? Let's add a new list here, and this new list will do the append for us. If I print the new list and I click run, I get none. That's weird. What if I print basket here? If I click run, all right. So it looks like the basket was appended to, we added 100, but a new list, when we assigned it the basket.append, that new list is completely none. And that is because append changes the list in place. What does in place mean? It means that it doesn't produce a value. All it does is saying, hey, I'm just going to append 100 to this basket that you gave me. But I don't really care. I'm not producing a result. I'm just changing this for you. I know it's a little confusing. So in order for our new list to have that 100 at the end, we have to do something like this. If I click run, there we go. After we've appended to the basket, then we can assign, so that new list points to basket, which points to this list that was modified. All right, what else is there? Well, there's also something called insert. And you see over here that insert gives an index and an object. So we can insert something, not at the end of the list. I mean, we could, but we can also insert it anywhere we want in an index. So for example, in this case, if I do insert 100 at 0, 1, 2, 3, 4, so let's do index of 4, and I click run, I've added 100 to the index of 4. If I do index of 5 and I click run, I've added 100 at the end of the list. Now let's try and copy this and see if we can just add it into here. If I click run, again, same thing. Insert modifies the list in place. It doesn't create a new copy of the list. All right, and if we add this like this, well, once again, insert modifies the list in place. That is, it doesn't really output a new list, it just modifies whatever is existing in memory. Finally, there is another method called extend. And extend, instead of an actual item or object, takes what we call an iterable, which we're going to get into later on. But it's something that you can loop over, you can iterate over, which is a list. So we just give it another list, like let's say 100 or 101. So if I run this, once again, it doesn't output a new list, it just modifies the list in place and adds on or extends our list. And we can also just give it one item. All right, let's keep going with the removing methods. Now, with the removing, we once again have a few fun things that we can do. So let's continue with this basket that we've been using that now has 100 included into it. And the way we can remove things is, well, there's a few ways. First one is basket.pop. And basket.pop, if I go like this, and let's print this basket, I'm going to comment out the new list for now, since we're not using it. And then we're going to say basket.pop, and then print basket. Let's run this. And pop pops off whatever is at the end of the list. In our case, at the end of the list, because we've extended the basket to 100, that 100 gets removed. If I do basket.pop again, not here, down here, and I run, you see that both 100 and 5 get removed. What if I do pop 0? If I click run here, it removes the item in the index. So here, pop 0 is going to remove whatever is at index of 0, which is 1. Now, there's also .remove. Remove, again, is we give it a value that we want to remove. So in our case, let's say we want to remove number 4. Well, if we run this, it's going to remove 4 for us. So remove, we give it the value that we want to remove. With pop, we give it the index that we want to remove. And just to see if this is working, let's add a new list here. And we'll say new list equals basket.remove. Add a new list here. See if that gets modified. Nope, it does not get modified. That means remove is working in place. It doesn't return a value. It just simply changes whatever list you give it. What if we do pop? If I run this, I get 5. Why is that? And this is something that you just have to get used to. Different methods do different things. For example, pop, the way it works is that pop returns whatever you have just removed. In our case, when we did 4, that is index of 0, 1, 2, 3, 4, it returned the number 5 for me. Even though it removed it from the basket, it still returned something. And the reason for others is that we got none. That is when a method doesn't return anything. It returns none, a topic we're going to cover shortly. So you have to be careful and understand what each method returns. If I go over extend, I see here that this little arrow shows me that none is returned. That means it's not going to produce anything with this method. It's only going to change or extend a list that it was given. Don't worry if this is confusing. That's something that you're going to get used to as we get more and more practice. Now, the last removing method I want to show you is clear. And clear, as you might guess, if I click run here, well, this is none. But if I go to basket and I click run, the basket is empty. Clear removes whatever's in the list, completely clears it, just as the name suggests. All right, that was a lot, but there's still a few more. So let's take a break, and I'll see you in the next video. Bye-bye. Welcome back. Let's keep going with some more string methods. Now we've learned about adding and removing ones. We learned about append, insert, and extend. And then in removing, we learned about pop, remove, and clear. There's a few other important ones. Let's go with the index. So instead of clearing here, let's clean this up. And we'll do basket dot index. An index, as you can see, we give it a value, a start, and a stop. What does that mean? Well, we want to say, hey, what index is number 2? If we do index of 2 and I click run, it's going to give me 1. I know this is a little confusing, but it's asking for the index. Where is number 2? Number 2 is at index of 1. Let's change these into letters just so it's more clear. So we have A, B, C, D, and then finally E. And again, if I do D here and I click run, I get an index of 3 because 0, 1, 2, 3. It's on shelf 3 in our memory. And you can also do a optional parameter here, which is where should we start looking? So I want you to start looking at index of 0 and then finish looking at index of 2. If I do run here, I get an error. It says, hey, D is not in list because, well, we started at index of 0 and stopped at index of 2. If I do 3 and I click run, no, it stops right before 3. So if I do 4 and I click run, there you go. I get 3. Now, errors are not good in our programs. Ideally, we don't want to get errors. So how can we avoid this? What if we're looking for something and we're not sure if it's in the list or not? There's another nifty way of looking for things in a list. And this involves what we call a Python keyword. A keyword is something that you use in Python that, well, already has some meaning. For example, a keyword here, if I go to Python keywords, are all these words that already mean something. Now, we're going to go through them, and we haven't seen a lot of them yet. But we might have seen true, right? In Boolean values, true means something. So in Python, we can't really use the word true because, well, it already means something. There's a word called in that, as you can see, as soon as we type, means something, is a keyword in Python. And this is quite nice. We can say, hey, is D in basket? And if I run this, I get true. Okay, is X in basket? I get false. Because, well, it doesn't exist. And this is actually quite useful, and we can even do it for strings. For example, if I'm looking for, let's say, the letter I in a word, and let's say it's I in hi, my name is Ian. If I click run, I get true because the letter I does exist in this string. All right, let's learn another one. Another one is basket.count. And we can count how many times an item occurs. So for example, if I do D and I click run, I get 1 because D only exists once in the list. But if I add another D in here and I click run, we get 2. It counts how many times this value occurs in our list. Very, very useful. All right, a few more still to go. Let's do some exercises and I'll see you in the next one. All right, it feels like it's never going to end. We have so many methods with lists, but like I said, lists have a lot of methods because you can do a lot with them. It seems like a lot right now, but trust me, these are going to become second nature. So hang in there. I have a few more to show you. The next one is called sort. Guess what sort is going to do? If I click run, I get none. But remember, sort sorts the list, as you can imagine, in place. That means it modifies the list. So if I remove this up to here and then do sort or do basket, and I click run, look at that. I get a sorted list where D was moved in front of E. If I add, let's say, X at the beginning here, and I click run, it's going to move the X all the way to the end. It's going to sort the list in place for me. Again, if I hover over, it sees that it's going to not return anything, which is why our print initially didn't work. We had to print our basket, not whatever this produces, which it doesn't produce anything. But what about this one? If we go to built-in functions, I have something called sorted. And if I do sorted, and because it's a function, not a method, I can do sorted dot or basket. So around the brackets, just like print. If I run this, all right, nothing has changed. But what if I remove this and put it in here? If I click run, I get A, B, C, D, D, E, X. What if I comment this out? So that we're not sorting it anymore. We just have the basket and then we run this sorted function. If I run, did you see that? Sorted, I know it's confusing. Why do they even have two? But sorted produces a new array. So if I do print basket here and I click run, the basket hasn't been modified. The basket still remains the same. It's this one over here that's not sorted. Sorted, on the other hand, doesn't modify the basket in place. Instead, it creates a new copy of the basket and sorts it. It's almost as if we're doing this. We're saying new basket equals basket, and then we're going to copy that basket. Remember, list slicing. And then we're performing new basket dot sort on this new list. So that if I do new basket and I click run, we get the same thing. So you have to be careful of certain actions that perform an action in place or create a completely new list to begin with. By the way, there's also, instead of this, a dot copy method that we can use. And if I run this, again, we get the same thing. Copy, just as the name suggests, copy the list for us and returns for us a new list. All right, one last one, and that is basket dot reverse. What do you think this does based on the name? Well, if I check out the basket here and click run, is that what you expected? It reverses the basket in place. But notice that it's not like sort. It's not sorting. It's simply switching all the indexes into opposite sides. So D is now index of 0, E is now index of 1, index of 2, 3, so on and so forth. So you can see here that it doesn't actually sort it. Instead, what we might want to do is sort first, then reverse, and if we click run, we have a sorted, reversed basket. This is a little tricky one that some interviewers might ask. All right, good job getting this far. We're almost done with lists. So I'll see you in the next video. Bye-bye. Welcome back. Let's talk about some useful tricks with lists that you'll see a lot in Python code. Well, one we have already seen. It's this idea of length. You're going to be using this a lot. That is to figure out the length of a list, which in our case is now 7. Another really useful trick is to reverse a list. Now, I've already showed you how to reverse a list, but sometimes you can do that with list slicing. Again, something that we've seen in string slicing. So I can actually do basket and then semicolon, semicolon, -1. If I click run here, is that what you expected? Let's go through this line by line. I've sorted the basket so that it's from A all the way to Z. And then I've reversed this so it's in Z all the way to A. And then I've reversed the basket again so that instead of being in reverse, it's now in order. A, B, C, D, EX. And this list slicing creates a new list, right? If I print basket here, you'll see that the basket is the reversed version, the last action that we've taken on it, versus list slicing that creates a new version. So this notation you'll see a lot with lists when you need to reverse a list, or maybe you need to make a copy of the list like this, or maybe you need a portion of the list. Another useful thing that you'll see a lot of is something called range. Let's comment this out for now. If I wanted to generate a list really quickly, let's say from 1 to 100, I can do something like this. I can say range and then start and then stop. So let's do 100. And if I print this and I run, I get a range 1 to 100. But if I wrap this in a list, which is going to create a new list for us, and I click run, look at that. I get a range from 1 all the way to 99. Remember, it's the start and then whatever to stop at. So before it hits 100, it's going to stop. Now, if I remove this and just do one single thing, I get a list starting from 0 all the way to 99. If I want a list that has 101 items because it starts at 0, I would just do 101. And range is something we'll talk about a lot more, especially when we talk about loops in programming. But this is a great way of you to generate a list really, really quickly, especially a numbered list. Finally, the last common thing that you'll see a lot is this idea of .join. What is .join? Join is actually something that works on strings. It's a string method. But it's often used this way. We have an empty string, and this empty string, let's say sentence. And then we can do sentence dot join, and join takes what we call an iterable, which is a list for now. And in here, we can have a sentence like, hi, my name is Jojo. And now if I print sentence and I click run here, I don't get anything. Let's figure out why. What if I type in an exclamation mark here and I click run? All right, it's printing out sentence, but it looks like .join creates a new item for us. So let's just assign that to new sentence. Now, if I do new sentence and print that out, we see that I get, hi, my name is Jojo. So this is a little funky, right? We have these exclamation marks between our items. And join joins these little iterable items, these lists, by whatever is in front of it. So if we actually change this to an empty string, click run, we now get this. If I add a space in between and click run, we get, hi, my name is Jojo. And sometimes you'll notice this pattern a lot, especially if you want to join and create a new string out of a list of items. Now, a shorthand way of doing this is to actually not even bother with this and just doing an empty string, .join, and then joining all the list items. There we go. So all we're doing is combining lists into a string, and this is a common pattern that you'll see a lot of. I'll see you in the next one. Bye-bye. I want to teach you one last thing when it comes to lists, and it's called list unpacking. And it's a really, really nice feature. I really like it. With list unpacking, we can do something like this. Let's say I have a list that is, well, very simple, 1, 2, and 3. And I want to assign a variable to this list. Let's call it basket equals 1, 2, 3. But what if I wanted to assign a variable to each item? Well, I can actually do something like this, A, B, C. So that when I print A, and then let's print B, and then print C, and I click run, I get 1, 2, 3. And this is something that we've seen when we talked about variables, where even if it wasn't a list, as long as we gave it by comma, separated by comma, different values, we're able to print 1, 2, 3. But this is where list unpacking gets really, really useful. We can actually, let's say, extend our list to include all the way till 9. What if we wanted to unpack 1, 2, and 3, but keep everything else still in a list? Could we still do that? Well, with list unpacking, we can. All we need to do is say comma, and then add a star, and give it a variable name, whatever we like. Let's say other. So now if I print other, and I click run, look at that. I'm able to unpack my list however way I want. What if I add a comma here and add D? Well, if I run this, I get a list all the way until 8. But now D is, well, actually, the very last item. So that's very, very neat. Maybe the use case right now is not absolutely clear to you, but this is something that might help you, another tool in your toolbox, to unpack a list and change a list in different ways. We'll explore this more later on in this course, but for now, list unpacking. When you hear that word, now you know what it means. I'll see you in the next one. Bye-bye. Welcome back. When we talked about lists, we saw our special type of none, where some methods that worked on lists didn't really produce anything. They modified the lists in place, but the output of whatever they were doing was this thing none. Remember how we had in the output this none? What does that mean? If you remember, I mentioned none as a special data type that exists in Python. And most languages have something like this to represent the absence of value. In some other languages, you might have heard of null, which is another thing that, again, represents the absence of value. Now, why is this useful? Well, for now, it's hard to really conceptualize it. We'll see it being used a lot more as we get further into the course. But I could do something like A equals none. Let's say, for example, we're just starting a video game. And in this video game, we have a user's weapons. But when you're just starting the game, there are no weapons that the user has. Well, in that case, we might want to assign the variable weapons. Maybe in our code, we use this variable. But we also want to know that this user doesn't really have any weapons. It's none. So this is completely valid Python. If I run this, I get none. And we'll explore this a little bit more throughout the course, like I said. But hopefully this way, you're not intimidated when you see it. As the name suggests, it's just nothing. Let's talk about our next data structure. And this one is called a dictionary. In other languages, it might be called a hash table, maybe map or objects. In Python, we have this idea of dictionary, or as Python likes to call it, dict. I have to make sure I pronounce that properly. That's a really hard word to say when you're recording and you're repeating it over and over. Anyway, dictionary. What is it? Well, it's a data type in Python, but it's also a data structure. Remember that I mentioned this idea of data structure when we talked about lists. They were the first data structure in Python that we learned. It's a way for us to organize our data in a form that has some different pros and cons on how we access it. For example, with lists, we saw that they're easily ordered. We can access them through indexes like 0, 1. We can reverse them. We can insert into them. It was really, really nice. What about dictionaries? Well, let's see what a dictionary looks like. A dictionary will look something like this. We'll have a key and a value. Then another comma, and then another key and another value. Let's decipher this. So I'm using curly brackets here, which denotes a dictionary. And unlike a list, we have what we call a key-value pair. A key is a string for us to grab the value. What do I mean? Well, in order for us to access any of these values, I would go dictionary and then say the key. In our case, let's say we want to grab B. We would grab the key, and then when we print here the result, we get the value 2. We're essentially telling the computer, hey, I have this variable dictionary. Remember, I can name this whatever I want. I have this variable dictionary. I want you to go find the key B. And this key B, if it exists, grab me the value. So it's going to go into your memory or into the machine's memory. It's going to find where B is stored in our memory and grab the value. So in the bookshelf B, we have the value 2. What if we do C, which doesn't exist? If I click run, nope, I get an error. It tells me, hey, sorry, you're looking for key C, but I don't really have that key. And this is what a dictionary is. A dictionary is an unordered key-value pair. What do I mean by that? Unordered means that they are not right next to each other in memory. Remember, with lists, we could access lists with index of 0, then index of 1, index of 2. All those bookshelves were right next to each other. A dictionary, on the other hand, they're all over the place. Although I've put A and B here, this might be in one spot in memory, and this one in another spot in memory. And if I added, let's say, X, this will be in another spot in memory. And this might not be in order. Maybe I've written it A, B, X, but when I actually return the entire dictionary, maybe I don't have this in order. These are all just scattered all across our memory. As you see here, when I receive the dictionary, I get these things in order, but that's only because it's small. If I had a really, really large dictionary, I might not have them in order that I've inserted it in. So a dictionary is an unordered key-value pair. And as long as we know the key, that is, whatever the key that we're looking for, then we just give that. And our computer is going to know, hey, where in memory to look to grab the values. Now, here's the cool thing about data structures, like dictionaries and lists. They're containers around data, right? So this can be anything that we want. Let's say we want this one to be a list, 1, 2, 3. Maybe we want this to be a string, hello. And maybe this is a Boolean value, like true. That is completely valid. I can access the A like so, and I get the list. What if I want the second item in the list? Well, I do index of 1, like this. And there you go, I get 2. And this is the same with lists. And you'll see this a lot, where if we had a list, or let's call it my list, and my list contains a dictionary that has, let's say, A, 1, and you know what? Let's just copy and paste this. We'll do this. So we'll have the first item in the array, like this, then comma, then another item in the array, and this time around, this one has 4, 5, 6. So that I can now grab from my list the first item in the array, and then maybe grab the A, that is the A key. So remember, this is a string. And then we want to grab, let's say, the third item. So we'll go 2. If I run this, I should get 3 and 2. There you go. Now, you might be asking yourself, what's the deal with these data structures? Like, why do we need dictionary? Why do we need list? Why can't we just have one thing that does everything? Isn't that simpler? Think about that, because in the next video, I'm going to try and answer that question for you. Let's talk about our next developer fundamentals. And this one is understanding data structures. A really good programmer is a programmer that is able to decide what data structure to use when. Up until now, we've learned about dictionaries and lists, and we'll learn about a couple more throughout the course. But a really good programmer, a programmer who's experienced, is able to understand what the trade-offs are, when to use what. And although I can give you a list of this is when you should do this, and this is when you should use maybe dictionaries, the thing is, this takes practice and experience. So throughout our course and then the exercises that we're going to do, the projects we're going to build at the end, I hope that this idea of understanding when to use what data structure makes sense to you. But let's go back to our example. When should you use a list and when should you use a dictionary? Well, the first thing we have to realize that a dictionary is not sorted, right? A list has order. It has 0, 1, indexes, so on and so forth. A dictionary has no order. So maybe if you want to have a list of people in line at your shop, well, you should probably use a list. But maybe you have a user that is playing a game, and that user has first name, maybe weapons, maybe an age. That doesn't have to be ordered, so you might use a dictionary. Also, you'll notice that dictionaries hold more information than lists, right? Because lists only have that single value. That is, a list has the index and then whatever the value is. And here we have a dictionary inside of a list, which is holding a lot of information. Deep down, a list is simply an index and some sort of value here, right? Versus a dictionary that holds a lot more information. It holds a key. So this could be the weapons of that user. Hello can be the greeting of that user. Maybe is magic is another information about that user. So we're able to have both keys and values in a dictionary. So it holds a lot more information. And as we learn different data structures, you'll have these different pros and cons. You'll start to understand as to when to use what. All right, there's another developer fundamentals. I'll see you in the next one. Bye-bye. Welcome back. I mentioned to you that a dictionary's values can hold any sort of data type. But what about the keys? Up until now, I've only used strings to denote a key. But could I do something like this? Could I do 1, 2, 3 like this? Well, let's have a look. Let's give it a try. If I do 1, 2, 3, and I click run, I get 1, 2, 3. Awesome, that works. What about true? If I have a key true and I click run, will that work? Yep, it looks like it works. What about a list? What if I have a list of, let's say, just 100? Would that work? If I click run, nope, it doesn't work. It says unhashable type list. What does that mean? Dictionary keys need to have a special property. A key needs to be immutable. That is, a key cannot change. And numbers, booleans, this is a value that cannot change. A string, if you remember, is a value that cannot change. It's immutable. But a list, if you remember, can be changed, right? On a list, I can reassign, let's say the index of 0 to something else, right? So because of that, a dictionary says, hey, my keys, because I'm storing them in memory and I don't want to lose them, it has to be something that isn't going to change on me. Maybe a programmer comes in and by mistake changes this array of 100 to have an index of something else. Well, dictionary doesn't really want that because it doesn't want to lose this value. So a dictionary key always has to be immutable. And as we learn a few other things like a tuple that we'll see in upcoming videos, you can use those as keys as well. However, most of the time, 99% of the time, a key for a dictionary is usually something descriptive like a string. Okay, but what about this? What if we have another string, 1, 2, 3? And let's just remove this for now. What happens when I search for 1, 2, 3, the string? If I click run, I get hello. A key in a dictionary has to be unique because there can only be one key, because that key is going to represent a bookshelf in that memory space. So anytime I do the same key and maybe add a value, it's going to overwrite. So this no longer exists. A key has to be unique, and it's something that can only exist, well, just once. Otherwise, we overwrite it, which is why you see hello here. We've lost the array 1, 2, 3. Let's explore this idea a little bit more in the next video. Welcome back. Now, if you remember, let's have something different here. So we have unique keys. If you remember, we have to have unique keys. So let's say this is greet, and this is a, I don't know, let's say a basket. And we can access basket like this. If I click run, I get 1, 2, 3. But what if we don't know what this dictionary is? Maybe a dictionary is something, well, somewhere else where we can't see. But we want to know if this, let's call this user, if this user has maybe property like age. So do they have this age key? Well, if I click run, I get an error, key error, age. Age doesn't exist. But remember, errors in our programs, and this is something we'll cover later on, are not good. They're going to stop the program as soon as the Python interpreters enters an error. It's going to kick out of the program and say, hey, you have an error, and it's going to completely ignore what's underneath it. Here we don't have anything, but in a real life program, we want to avoid these errors because it stops execution. So another good way to access a key and to see if it even exists is to use .get. And guess what .get is? Did you guess a method? Well, there you go. .get is a method on the object or the dictionary in Python. So here, if we do get age and do run, I get none. So my program doesn't error. It just says, hey, there is nothing there. It's an absence of value. And we've learned what none means by now. So that's a really nice way to avoid those errors. By the way, if let's say there's no age in the user, but you want to have a default value, you can do something like this. So you add a comma, and then here you say whatever you want as the default value. So let's figure that out. If I click run, I get 55. Because now I'm saying, hey, grab the age from the user dictionary. If age doesn't exist on the user dictionary, use 55. So now we have 55. But if the user already has age, and I click run, I get 20. So this is, hey, in case age doesn't exist, add a default value. That's really, really nice. Now, I'm going to show you another way to create a dictionary, which is not very common. Most of the time, you want to use this syntax. But just so you're aware of it, here's another way. Let's say we have a new user, so user 2. I can create here a dictionary by saying dict, which again is a built-in function. And in here, look at that. It shows me, hey, this is going to create a new empty dictionary, and we can create different values, key value pairs. And we simply say, I want the key to equal the value. So in my case, let's just say that I want the name to equal John John. If I now print out user 2, well, before I click run, I see that I have a red underline. And by the way, if you see here PyFlakes, that's something called linting, something we'll talk about when we talk about developer environments. We're using this linter that tells you whenever you make errors in Python, and it says keywords can be an expression. That just means that, hey, the keyword needs to be, well, just a variable that we create. So if I click run here, look at that. I have name John John. So we've created a user with this key value pair. Now, like I said, this way of creating dictionaries is not very common. Most of the time, you'll do something like this, but at least now you know that this is why this built-in function exists. I'll see you in the next one. Bye-bye. By the way, there is actually one more way that we've actually seen in lists how to look for an item in a dictionary. Remember how in lists we used the keyword in? We said something along the lines of, hey, is I in a list that contains I? Or we even used a string like hi. Well, you can do the same with dictionaries. I can say, does basket exist in user? And let's print this out and run. And it's going to say, yep, basket does exist in user. What about size? Does that exist? Nope, that's false. That does not exist in user. But here is where it gets really interesting. And this, again, is another dictionary method that we can use. And by the way, you can see that there's not that many dictionary methods that, well, dictionaries have. Luckily, we're going to go over the main ones here. The one is called keys. And keys simply checks the keys. What are the keys of user? So if I go hello here and I click run, well, no, keys are, on this side, not this. So this is a value. So if I want to check keys, I'd say age, which is true. But if I want to check values, well, in that case, if I do hello, I get true. It's going to go over, or what we call iterate, over the values. Another one that's really useful is the items. And items is special because we've seen keys and values, but items actually grabs the entire item. So the way we can actually see this is, let's just remove and click run. All right. This is interesting. I have dict items here, and I grab, looks like a list, and in here we have a bracket, basket, 1, 2, 3, greet, hello, and age 20. But there's some weird syntax here that we haven't seen before. And this is actually a tuple. So we're going to hold off on this and talk about this a little bit more when we talk about our next data structure. But keys, values, and items is an easy way for us to grab these things for us from our dictionary. Let's continue on with other dictionary methods that we might use. One is a very nice one. It's called clear. And if I run this, you see that I get an empty dictionary. What if I just run users.clear here and run user? Well, it's still an empty object. or an empty dictionary. So you can see here that clear doesn't actually return anything. It doesn't, well, it's just in place, removes whatever the dictionary has. So it just creates an empty dictionary. What about copy? Well, a copy allows us to copy a user so that if I print user and user2 and I click run, I get 2 users, each keys and values copied. But if I now, let's say, clear the first user and I click run, the first user is empty, but because I've copied the second user has the old information. And this is a concept that we've talked about before. Another useful command, and let's just go back to having user, is user.pop, which removes a key and a value from the dictionary. So in our case, let's just say we want to remove the key that is age. So I'm going to say age. And if I run this, I get 20 because pop returns the value of whatever got removed. But if I do print user now, you'll see that age does not exist anymore because we've popped it off. But pop, as you can see, removes the actual value or returns the actual value 20. Here's another really fun one, pop item. And honestly, this I haven't used much, but I just think it's a fun one. Pop item, if you guessed, well, you're not going to guess. Oh, and that's because I have to make sure I write it properly with lowercase. If I run this, what just happened? It randomly pops off something. One of the keys and the values. In this case, age 20 is removed. So the last item on the dictionary gets removed, but remember, a dictionary is unordered. So if this was a massive, massive dictionary that, well, doesn't have any order to it, sometimes it removes some pair, as you can see, not the last one, but some pair of key value. So you have to be careful with this one. It doesn't necessarily just remove the last thing that you entered, but it might be useful on some occasions. Finally, we have something called update. An update simply updates, as the name suggests, a key value. So let's have a look here. All we have to do is give it a new dictionary, so curly brackets, and just simply say, hey, I want to update age to 55. If I click run, oh, and I forgot a bracket here. Let's try that again. If I click run, there you go. Age got updated. But if this was a key that doesn't exist, like ages, and I click run, it will still update with a new key item. So this is another really useful method. All right, that's it for dictionaries. I'll see you in the next video. Hooray, it's time for our third data structure as we continue down to our different data types in Python. And this one is called a tuple or tuple, depending on how you like to pronounce it. And we actually saw this slightly when we talked about dictionaries. But before we get into that, what are tuples? Well, a tuple are like lists, but unlike lists, we cannot modify them. They are immutable. So you can think of them as immutable lists. And they look like this. So let's call it my tuple is going to use brackets to denote a tuple. And we can do 1, 2, 3, 4, 5, just like a list. Now, you remember how in a list, we could have modified this and said index of 1, well, now is going to equal z. If I run this, it's going to error out. It's going to tell me, hey, tuple object does not support item assignment. A tuple is immutable. Once you create it, it's the way it is. You can't sort it or reverse it like we saw with lists. It's just there. What about this? Can I just print a tuple and just grab the second item on that tuple? Well, yes, you can. Just like a list, you can access it through an index. Can I maybe does 5 exist in my tuple, just like we could in a list? Well, yes, we can. The difference is that it's immutable, right? Now, why do we need this? I mean, we already have lists, so why do I have to learn tuple if, it's pretty much the same as list? The only thing is I can't change it. There's a few benefits to this. For example, if you don't need to change the list, that makes things easier because it tells other programmers looking at your code, hey, this shouldn't be changed. Unlike a list, I want this to stay the way it is. Keep this order. So it makes things easier and more efficient. It makes your code safer because people can modify it, right? It makes code more predictable. However, it makes code more predictable, but it's less flexible than a list. I can't really sort a tuple. I can't run reverse on tuple. Now, because of this, because they are less flexible, the other good thing about them is that they're slightly more performant than lists. So they're usually faster than lists. And if you don't need a list to change, well, use a tuple. So a good use of a tuple, for example, if you work at Uber, is geographic location and coordinates, right? You can have latitude and longitude here. And because, let's say, this won't change, or maybe a user's location or pickup point doesn't often change, we can just use a tuple. However, maybe when you're in a car as a driver and you're an Uber driver, well, you probably need your coordinates, your latitude, longitude in a list because your car is moving. That's constantly changing. And we saw tuple when we talked about dictionaries, right? Remember when we did user or we did user.items? And then I said, hey, just print user.items. And we saw here that we got a dictionary items. And inside of this dictionary, we see that basket 123, greet, hello, and age 20 are a tuple. So this actually returns our key and value as a tuple. And as I mentioned before, a dictionary can have keys that are immutable. So a tuple is a completely valid key in Python. So I can do 1, 2 here, and that is a valid key in a dictionary. And the way I would access this would be like user, curly bracket, 1, 2. So that if I click run here, oh, I have an extra bracket. Let's fix that. Let's click run again. And there you go. I'm able to grab user, tuple 1, 2, and grab 1, 2, 3 list. You see here how I'm trying to use different data structures, combining them together. Let's take a break and finish off our understanding of tuple in the next video. Now, tuples, like I said, are quite similar to lists. So if I wanted to, I can say new tuple and use my tuple and then slice that tuple. So for example, if I do 1, 2 like this and print new tuple, I'm going to get 2, comma. Why is that? Well, we start at 0, 1 and end at 2. If I did 4 here and click run, I get 2, 3, 4. It's still a tuple, but you have to remember that a tuple that only has a single item tends to have this little comma at the end, but it's still a tuple. And just like a list, I can assign different things. For example, I can say x equals to my tuple 0, and then I can say y equals my tuple 1, and x and y will equal 1 and 2. But a short form of doing this, again, similar to lists, is to say, hey, I want x, y, z, and you know what? Other to be the values assigned from the tuple. So that if I do x here and I run, I get 1. If I do Z and I run, I get 3. What if I do other? And if I click run, I get 4 and 5 as a list. All right, if your head doesn't hurt by now, don't worry, I have some good news. Luckily for us, a tuple has only 2 methods that we care about: count and index. How nice is that? So nice and simple. Guess what these mean? So let's go back to my tuple and now try these out. If I go my tuple.count, well, it's going to count the value. So if we want to count how many 5s occur in the tuple, I get 1. If I had another 5 in the tuple, I get 2. What about index? What's the index of 5? Well, the index of 5 is 4. Because 0, 1, 2, 3, 4, the first value that it finds, it's going to return the index of. And then finally, we can also do length, right? We can use this built-in function to run length, and it's going to tell us that, yep, it has a length of 6. Awesome. There it is. We're flying through them now. This is our third data structure. Remember, they're simply lists that are immutable. I'll see you in the next one. Bye-bye. Can you believe it? I hope I didn't put you to sleep, but we're almost there. We have one last main data type, set, and then we're done. I know this isn't the most exciting topic. Trust me, this is the hardest part. When you're starting out and you're just learning these things without understanding, why do I need this? How am I going to build the next game? How am I going to build the next Netflix? How am I going to build the next coolest Apple app? You're looking at this and thinking, I just learned a bunch of theory. I feel like I'm in math class all over again. I know, trust me, I went through this. I was a self-taught programmer as well. These are the Lego blocks that builds our foundation. Once we learn these, we can move on to new things, and you'll see that once you climb this little mountain, things become so much easier. And you'll realize the power when we start building these projects toward the end of the class, where you're going to say, oh, all these blocks that we learned, all this frankly boring part is all going to make sense. So hang in there. It's supposed to be hard. It's supposed to be tough, but you'll see very soon why this is so powerful and why what we've just learned is going to allow us to build some really awesome things and create some really awesome programs. So let's finish off with the last one. The last data type, the last data structure that we'll see in Python, at least from the main ones. And it's called set. And sets are simply unordered collections of unique objects. Let's have a look. Let's create a my set. And my set we create with curly brackets like a dictionary, but instead of a dictionary, we don't have key value pairs. Instead, we just have values like 1, 2, 3, 4, 5. That's it. That's a set. We just created a set. But remember the definition I gave you. Set is an unordered collection of unique objects. What does that mean? Well, if I print this and say my set, and I click run, I get a set. But if I had, let's say, another 5 in here, and I click run, it only returns the unique sets or unique items. You see, in a set, there's no duplicates. Everything has to be unique. So this 5 just never gets added to a set. For example, you can add things to a set like my set, and then I can say .add and give it a value like 100. And then let's say I do my set.add and then give it 2. If I click run here, I see that I was able to add 100, but 2 wasn't really added because my set already contained that data. It's unordered. I mean, we've created 1, 2, 3, 4, 5 here, but there's no real order to it. There's no bookshelf in our memory space that is right next to each other. these are all over the place in memory, but a set is able to find them because they're all unique. So they're all in just one location in memory. So let me ask you this, and this is going to be a fun little exercise. If I gave you an array, and let's say this array contained, well, this right here. And I want you to return an array with no duplicates. So I want everything in, let's call it my list. And a programmer has already created this. Okay? And then your task is to create or return a list or a collection that has only unique items. How would you go about converting this into a set? Well, we've seen this before. We have a set function, and we simply wrap my list in that set. And let's print it out. I click run. Check it out. We have formed a new set from a list. And I've removed all duplicate values. When would this be useful? Imagine if we had usernames, right? Or email addresses. We're collecting email addresses on our startup page, but we don't want to have duplicate emails. We might want to convert this, a list of emails, to a set and remove any duplicates so we're not sending emails over and over. So that's really cool. What about this? Let's change this into a set. So let's call it my set. I'm going to change this into a set. There you go. And then what if I wanted to access my set at index of 0? Set object does not support indexing. Well, again, you can think of it more as a dictionary. In order to access a set, we have to grab by the item that's in it. That's the key to getting the information from memory. The way we would check if something exists is we simply say, hey, is 1 in my set? And we run this, and we get true. We can also do length of my set, and we get 5. Again, nothing too crazy, but 1, 2, 3, 4, 5. Remember, it only counts the unique things because this will never get entered. It's a set. And alternatively, we can also convert this into a list. If I click run here, you'll see that I now have my set as a list. And then we can also do, let's say, my set.copy, and actually copy my set into something, let's say, new or new set. And then this will be completely different or a new copy than this original one. So let's test this out. This new set, if I use a method that we may have seen before, which is my set.clear, which as you can imagine, clears the set, and I click run, I have that new set, but when I try and print our old set, which was my set, it's going to be empty, an empty set. But the true power of sets comes in the next couple of methods that I'm going to show you. And sets have quite a few methods, but don't worry, most of them are quite similar. So let's explore that in the next video.